Hello everyone, welcome to Pre-GATE 2026 Computer Science and Information Technology organized by ACE Engineering Academy. Myself, I am Dr. C.H. Srinivas Rao, Associate Professor in ACE Engineering Academy. In this video, we will discuss in detail solutions step by step which gives conceptual clarity and strong foundation in the basics. And before proceeding to the solutions, there is a small announcement. ACE Engineering Academy is also conducting one more free mock test on 1st February 2026. And the last date for registration is 31st January 2026. So I hope this mock test also useful for you. So please do register before 31st January 2026.
Hello students, in this video, here I'm going to solve the solutions, I'm going to discuss with you the solutions of our pre-GATE exam from engineering mathematics. So they say that A is a 3 cross 3 real matrix. This is its characteristic equation, where A is having LU decomposition, L is lower triangular, U is upper triangular, and then what he wants, the value of trace of A inverse plus determinant of L. And he also says that L is a lower triangular matrix with unit diagonal elements. Now when he says L is a lower triangular matrix with unit diagonal elements, so how does L look, students? Unit diagonal, so you have 1 in the principal diagonal. Since it is lower triangular, this has to be 0, and you will have some elements here. What is determinant of L? The determinant of L is, since it is lower triangular, product of the principal diagonal elements, it is 1 into 1 into 1, which is 1. So we know this part. Now we need to find trace of A inverse. How do you find trace of A inverse? Let us say lambda 1, lambda 2, lambda 3 be the eigenvalues for A. We know that if these are the eigenvalues of A, then 1 by lambda 1, 1 by lambda 2, 1 by lambda 3 are eigenvalues of A inverse. This is a very basic point. These are the eigenvalues of A inverse. So he wants, what he wants, he is asking trace. Yes, trace of A inverse. Okay. So trace of A inverse is you have to add trace of any matrix is also equal to the sum of the eigenvalues. So this is 1 by lambda 1 plus 1 by lambda 2 plus 1 by lambda 3. Can you simplify this? After multiplication, it will be lambda 1, lambda 2, lambda 3 here, and then it will be lambda 2, lambda 3 plus lambda 3, lambda 1 plus lambda 1, lambda 2. So this will be the trace of A inverse. Now how do you extract this quickly? Now those who know how to deal with cubic polynomials or any other higher degree polynomial, they'll very easily answer. First of all, this is nothing but it is sum of product of the roots taken 2 at a time. What is this? This is, suppose if lambda 1, lambda 2, lambda 3 are roots of a cubic polynomial, do you know what does this numerator indicate? It is sum of product of the 2 roots taken at a time. So what was the polynomial or the characteristic equation of A given? It was lambda cube minus 6 lambda square, okay? It is lambda cube minus 6 lambda square plus 11 lambda plus 6 equal to 0. For a cubic polynomial like this, if you want this value, students, then you need to focus on the coefficient of lambda. Coefficient of lambda, which is 11, indicates sum of product of roots taken 2 at a time. So the numerator value is 11, and the lambda 1, lambda 2, lambda 3, it is product of this, product of the roots. For a cubic equation, we actually do like this. So what is this coefficient? Minus 6. If you put a minus to that, it is 6. That 6 indicates sum of the roots, that is lambda 1 plus lambda 2 plus lambda 3. Now alternately it is minus and plus sign. Here it is plus 11, which indicates sum of product of roots taken 2 at a time, and then alternately it is now a minus sign here. So I think it is minus 6 here. So let me correct this coefficient is minus 6. Like I was saying, here you have to put a minus sign. So minus of minus is plus, lambda 1 plus lambda 2 plus lambda 3 is 6, and directly you have to take this 11, lambda 1 lambda 2 plus lambda 2 lambda 3 plus lambda 3 lambda 1 value is 11, and again a minus sign. Minus of minus 6 is 6, which indicates lambda 1 into lambda 2 into lambda 3 is 6. So we have a trace of A inverse, we also have determinant of L. So what's the final answer? Trace of A inverse plus determinant of L is asked, that is 11 by 6 plus 1. If you do this, it is 17 by 6. The answer to this problem is 17 by 6. So let's go to the next problem. They gave matrix A and they are asking what's the product of diagonal elements of U, where you have that LU as the like LU decomposition concept, where L is a unit lower triangular matrix, U is a upper triangular matrix. Students, in this, if you see in LU decomposition, students, how do we write A? We write like A is L into U. What is determinant of A? It is determinant of L into determinant of U. Since L is a lower triangular matrix with all the principal diagonal elements as 1, the determinant of L is 1 into the determinant of U. So come on, what is determinant of U? It is exactly the determinant of A. There is no need to do any LU decomposition here. You can directly get the determinant of U by finding the determinant of A. So come on, go ahead, find the determinant of A. The determinant of A now is 2 into 50 minus 18 minus 4 into, it is 10 minus 6, and then plus 4 into 3 minus 5. How much is this? 32 na? This is difference is 32, and then into 2 is 64, and then this is 4, and then this is minus 16, this is minus 2, so this is minus 8, correct? 3 minus 5 is minus 2 and minus 8. So this is 24, I think this is 24 here. 64 minus 24, 64 minus 24, is it 40? The answer to this problem is 40. So what is he asking? He gave a cubic polynomial, okay, defined on the closed interval 0 to 3, okay. Let C be the value or values that satisfy the Lagrange's mean value theorem for f of x in the interval 0 to 3, okay. If m is the absolute max and small m is the absolute min on this closed interval, calculate the product of all possible values of C multiplied by m minus m. So what are we supposed to do? Find capital M, small m, capital M minus small m into product of all the possible values of C. This actually looks very lengthy question. So now what shall I do? It's a closed interval problem, so let us find the maxima minima. How do we find the maxima minima? So closed interval problem, find the stationary points. So you'll have two stationary points. It is 6x square minus 18x plus 12. You equate this to 0. So in that process, I get x square minus 3x plus 2 equal to 0. I think the roots are 1 and 2 here. So if you factorize, the roots would be 1, 2. So now at what points you need to analyze is, you need to find f of 0, you need to find f of 1, you need to find f of 2, and you need to find f of 3. Can you get us what is f of 0? It is easy among all, it is 5. F of 1 is also easy thing, it's 2 minus 9 plus 12 plus 5. So how much is this? This is minus 7 and this is 17. 17 minus 7 is 10. F of 2, f of 3, you have to find it properly. 2 into 2 cube. 2 cube is 8. 8 2s are 16. Okay. 2 square 4. 4 into 9 36. And then plus 24. Then plus 5. So please be careful with this. How much is this? Is it 40? Yes, 40 minus 36, 4. 4 plus 5 is 9. And f of 3. 3 cube 27. 27 into 2 is 54. Minus 3 square is 9. 9 into 1. 9 into 9 is 81. Plus 12 3s are 36 plus 5. So come on. 54, 36. Is it 4, 90? Yeah, 90, 95. 95. And then, yes, this is 90. And then this is 95. And then 95 minus 81. Is it 14? So please verify this. This is 90. So you can use virtual calculator also. 40. This is 90, 95, and then 14. So now what we understand from this is we need to identify what is capital M. What does capital M denote in this discussion? Absolute max. So what's the absolute max? So this is the absolute max, capital M. Where's the absolute min? Among this, which is the smallest value? The smallest value is this. So now I have M minus M. What is M minus M? 14 minus 5, which is 14 minus 5, which is 9. But we are still, we need to find the values of C. Let's go to the next slide. He's also talking about Lagrange's mean value theorem. So in Lagrange's mean value theorem, what we do is we write like this: f of C is equal to f of B minus f of A by B minus A. Substitute all this information. What is f dash of C? F dash I have calculated here. Substitute C into this, which will be 6C square, which will be 6C square minus 18C plus 12 equal to end points are what? 0 and 3, na? 0 and 3. I have already calculated f of 3, 14. It's ready with me. F of 3 is 14. Okay. F of 0 is 5. Okay. So f of 3, 14 minus f of 0 is 5 divided by 3 minus 0. This is 9, and then this cancels this by 3 times. When this 3 goes here, it is 6C square minus 18C, is it, plus 9 equal to 0. And then you can take 3 out. It is 2C square minus 6C plus 3 equal to 0. Now you have to solve for this, get the possible values of C. So C is 6 plus or minus root of 36 minus 4AC. So 2 into 3 is 6, 6 into 4 is 24 divided by 2A. 2A is 4. So this is 6 plus or minus 36 minus 24 is 12. Root 12 is 2 root 3. So this is 2 root 3 by 4. Now after cancellation, it is 3 plus or minus root 3 by 2. Now you need to check whether these values are in the interval or not. So 3 minus root 3 is, yes, 3 minus root 3 by 2 is definitely a value between 0 and 3. 3 plus root 3. 3 plus root 3. Root 3 value is, let's say, smaller than 2. So 3 plus 2 is 5. 5 by 2 is 2.5. Yes, both the values are actually in the interval. Both the values are actually in the interval 0 to 3. So he said take the product of possible values of C which satisfy LMBT. So we need to take the product 3 plus or minus. So one value is 3 plus root 3 by 2 and other value is 3 minus root 3 by 2. So this resembles like a plus b into a minus b, a square minus b square. It is 9 minus 3 by 2 into 2. 6 by 4, 6 by 4, how much? 6 by 4 is 3 by 2. So now you have the possible, like the product you have. Now you have to multiply this with m minus, capital M minus small m. So final answer. What's the final answer? It is this 3 by 2 into capital M was 14, small m was 5. I think this is 9. 9 3s are 27. 27 by 2 is 13.5. So fill your blank, that answer, with 13.5. So let's go to the next problem. So what does he say? X and y be two independent normal random variables. X has got a mean of 10, variance of 4, and y has a mean of 15, variance of 9. A new random variable is created, w, which is 2x. So what is w? It is 2x minus y plus 5. If phi of z represents the CDF of the standard normal distribution, then what's the probability of w greater than 10? So now here this 2x minus 5 is nothing but the linear combination of two independent normal random variables, and then a constant phi is added. So I'm very sure when you take the linear combination of two independent normal random variables, the linear combination is again a normal random variable, and this 2x minus 5 is added with a constant, so the new random variable is also normal. So final conclusion is w is normal. I want to find the mean of w. It is 2 into the mean of x minus mean of y, and the mean of a constant is the same constant. It is 2 into mean of x, 10, minus mean of y. What's the mean of y? 15, and then plus this constant 5. So this is 20, 20 minus 15 is 5, 5 plus 5 is 10. Let's see what is variance of w. So you can ignore this constant. This constant doesn't appear in our variance calculation, so ignore it. So because you know variance of ax plus b is a square into variance of x. So the constant disappears in the variance properties. So what is variance of 2x minus 5? And also he says independent, so there won't be any covariance term. The variance of this will be 4 into variance of x plus, yes, plus, it is variance of y, and then that's it. Okay, what is variance of x? 4. So 4 into 4 is 16, plus what is variance of y, which is given here? 9. So it's 25. So finally what you know about w? W is also a normal random variable with a mean 10 and variance as 25. What are they asking? They are asking probability of certain event. The probability that w is greater than 10. Probability that w is greater than 10. So we have concluded that w is a normal random variable. So the moment you conclude that w is a normal random variable, there is a process in which you can convert this discussion to a standard normal random variable. So that is w minus, let's subtract the mean. What's the mean? 10. So let's subtract the mean. So this will be like 10 minus 10. Let's also divide it by the standard deviation. So w minus 10 by the standard deviation. So just now we have got the variance of w is 25, so the standard deviation is 5. So this has to be greater than, what is 10 minus 10? 0, and then 0 by 5. You can now replace this quantity with z, because anything which resembles like x minus mu by sigma will behave like a standard normal random variable. So this is replaced with z. So now z greater than 0. We know the probability of z greater than 0 is 0.5. Do we have such options? The probability of this event now is 0.5. Do we have such options? We don't have such direct answers, but the answers are in the cumulative distribution function of the standard normal random variable. That's so simple. I can write the same probability as 1 minus the probability of z less than or equal to 0. The probability of z less than or equal to 0, you can write it in like CDF form, which is nothing but 1 minus, this is phi of 0. So try to recollect this. For a standard normal random variable, you can define the CDF. So how do you define the CDF, students? Suppose if it is phi of k, it is the probability of z. This phi is reserved for that standard normal random variable. It represents the probability of z less than or equal to k. So now right now we have probability of z less than or equal to 0, which is nothing but phi of 0. So hence the probability of this event is now 1 minus phi of 0. If you want its value, it is 1 by 2, because this is 1 by 2, 1 minus 1 by 2 is again 1 by 2. So, but we have this in the CDF form, so you need to choose the answer as option A. So these were the questions which were given the pre-gate, and these are the solutions. So thanks for watching this video.
Yes, students, so see this question. Here the statement is P implies Q here. P implies Q. P implies Q is true. And also Q implies R is true. If these two statements are true, if these two premises are true, by using hypothetical syllogism, then P implies R never be false, right? By using the rules of inferences, the property called hypothetical syllogism, just appears like a transitive property. So P implies R never be false. That means in this conditional statement, if this X part is true, Y part never be false. Hence you can say that it is a tautology. And moreover, the antecedent part is logically implies the consequent. Logically implies if X is true, Y cannot be false. This statement is also true. And coming to C, S is logically equivalent. P implies Q is true, and Q implies R is true, and also P is true, right? What do you say? P implies Q is true. Okay, the second premises is P implies Q is true, and the third premises is Q implies R is true. Q implies R is true. From these two things, just by using hypothetical syllogism, I can derive P implies R. And after that, I also have one more premises called P here. If P is true, then definitely the result R can be true. Yeah, you can call it as modus ponens. So we can say the statement C is also true. But don't say that option D, S is a contradiction, don't go for it. So that is the simple way. By using properties truth table, you can go for it. By using the logical approach, you can solve this question in simple way like this. And see this question. Here, the order of the given group is 8. By Lagrange's property, we know that order of a subgroup always divides order of the group. Hence, you can say the order of the subgroup can be either 1 or 2 or 4 or 8. These are the possible factors for 8. And we know that the size of H is strictly less than 8 and strictly more than 1. These two are not possible. So the order of H can be 2 or 4. When we don't have any confirmation, it can be 2 or 4. If order of H is 2, if it is a prime number, then definitely it can be cyclic, right? A group of prime order can be cyclic, right? But we are not sure about it. Order of H can also be 4. So in simple way, we can say that H may be cyclic, may not be cyclic. And the given group G also may be cyclic, may not be cyclic. So option D is correct. Both H and G may not be cyclic. May be cyclic, may not be cyclic. And see this question. Let G be the given graph with n factorial vertices. When we have n factorial vertices, the distinct permutations are possible in this 1, 2, 3, so on n. right? So there is an edge is possible permutation of two vertices can exactly swaps two times. My dear, when we have n labels, in all n factorial vertices, you can take two swaps at any number of times, equal number of times you can take. But if you take only one time, one swap, let us suppose the vertex consists 1, 2, 3, 4, 5. One swap can be possible, just like 2, 1, 3, 4, 5. Then here, the parity is preserved only one time, that is odd time. Let me take the something like 1, 2, 3, 2, 1, 3 and 5, 4. So here two adjacents are going to be swapped. This can be done by equal number of times. So this can be adjacent vertex, but this one not adjacent vertex, which indirectly means that degree of every vertex in the graph is same. If every vertex is having same degree, by using regularity, you can say that degree of every vertex is the same. It's a regular graph. Option A is correct. And when we are taking the swapping two times, so adjacent vertices are swapped two times, all even number of vertices comes under one component, all odd number of vertices comes under another component. So the components comes to 2. So we can say the connected components comes to 2. So option B is also correct. But we cannot say about bipartite because we are not sure about odd length cycle here. If you don't have odd length cycle, then only it will become bipartite. If you take n is equals to 3, in that case something like odd numbers, odd cycle is possible. So we cannot confirm about C and D. We can say option A and B are correct answers. Okay. And also in generating function, we have some question like this: an is equals to n and an is equals to 2, and different options are available. So you just see this question, when you are having an, so the an sequence comes to like this. The sequence is just like a0, a1, a2, a3, a4, a5, so on like this. So when n is odd number, what we have, it is simply 2. Yeah, it comes to 2 here. Here also it comes to 2. Here also it comes to 2. When n is even number, it is itself, just like n itself, 4 itself. And next number can be 6. For 0, it does not mention anything. So this is the real number sequence we got. Now for that real number sequence, if you take the corresponding polynomial, what we can get? We can get 0 into x power 0 plus 2 into x power 1 plus 2 into x square plus 2 into x cube plus 4 into x power 4 plus 2 into x power 5, right? It is just like a miscellaneous series, right? You cannot find this in any of our problems. But if you go to the options helps you a lot. In options, all options consist 1 minus x, 1 minus x, 1 minus x like this. And you know this 1 minus x expansion. 1 minus x expansion comes to 1 plus x square plus x cube plus so on like this. And 1 minus x whole power minus 2 expansion is, it comes 1 plus 2x plus 3x square plus 4x cube plus so on like this. In options, in all options I have this area, right? This area, right? This area. It's common, right? So if you take 1 minus x square whole power minus 2, it comes like 2x square plus 3x power 4 plus 4x power 6 plus so on in this way. Now if you take option B, my dear, option B comes to 2 into, here I am discussing option B, 2 into 1 minus x whole power minus 1 plus x square into 1 minus x square whole power minus 2. Now which is equals to 2 into 1 minus x expansion I have given. 1 plus x square plus x cube plus so on like this. And this area comes to x square into 1 plus 2x square plus 3x power 4 plus 4x power 6 plus so on like this. Now, my dear, you compare everything like this. Yeah, 2x here and 2x power 4 here. So, if you compare, it comes under 4x power 4 like this. And if you take x cube, term, my dear, if you take x cube term, it is 2x cube here, and it is also comes under 2 into x cube, 2x cube, and next term comes to 2x4. My dear, option B is the only one. You don't bother about constant value. In all other comparisons, the closed form of the expression comes to option B, right? You can also verify. Okay, here? Fine.
Yeah, dear students, this is a question related to the NOR gate. To design the NOR gate here, examiner was given, there's a Boolean function was given. So design by using NOR gates. To design this function, how many number of NOR gates are required? 2 input NOR gates clearly given. So first of all, to design the NOR gate, what is a given function here? This given function here, this is a given function here. Given function f equal to, so we can write f as a 2 times here f bar. I will write 2 times here. First of all, what is a given function here? Given function equal to a bar plus c. A bar plus c. Now product of a plus b. A plus b. So this given I am writing as a 2 times complement here. First time and second time. Both are going to cancel. Again you will get the same only. Okay, a function is written as a 2 times complement cancel again original. So here we have to simplify the first complement inside. So simplify the first complement. After simplification of first complement, tell me here. After simplification of first complement. So a plus c, this is a bracket here, a plus b. Now here dot is there. Suppose this total time is x, this total time is y. X into y whole bar equal to what, guys? Come on, tell me. X bar plus y bar, dear. Because of dot plus, okay, inside bracket, this white color. Again yellow color is remain same only. Yellow color is remain same only. Now this inside bracket is a bar is there. A bar. So this is a bar here. Design by using logic diagram here. Okay, design by using logic diagram here. How to design the logic diagram here easily? For this one, first one, a bar c here. Design using logic gates. Okay, now a bar c whole bar. This inputs observe here. A bar, this is c. So you will get the a bar plus c complement here. Okay, this term we got it. Next to a plus b complement here. A plus b complement here. A plus b complement here. Correct. A plus b complement. Now, okay, after this one, this 2, you can add to the one more NOR gate here. One more NOR gate. Now, this total design, so this simply you can write as f only, dear. F. But in the question paper, read clearly. Now, any complement inputs are available here. Word is given. Any complement inputs are available. Word is given, not given. So, the word is not given means so this input we are applying directly input. So, apply the one more NOR gate here. One more NOR gate here for this one. Now, this A, if you apply A bar, you will get. So, total number, tell me, dear students. This is a 1, 2, 3 and 4. So, to design this one, correct answer is 4 is correct answer. To design this given function, how many number of NOR gates required here? Correct answer is 4, dear. Now, read this question. So, correct answer for this question is 4. 4 is the right answer. Now, one more question, Boolean function related here. Simplification of the Boolean function, easy. What is a given function here? This is a given function. Already we know this total is x, this total is y here. X dot y. Help me anyone, x dot y complement equal to x bar plus y bar, dear. Correct. So, that thing I am writing here, f equal to a bar plus Now a plus b complement. Now this a plus b complement, this total term, because of dot you will get the plus, this whole bar divided into 2 dear. Now b bar plus b plus c complement inside. Now okay, whole bar. Let us, what I am writing here, inside f equal to a complement. A plus b complement is nothing but a bar product of b bar here, correct. Now this again overall complement plus this is a b bar plus b bar c bar here, again complement here. So from this one take the a bar common here. If you take the a bar common, what happens here? If you take the a bar common, 1 plus b bar, again whole bar is there, plus in this one b bar take the common here. If you from this to b bar take the common, 1 plus c bar, again complement. 1 plus something is 1 only dear. This 1 plus something 1 only. This 1 plus something is 1 only. So finally we are getting, what is the answer here? F equal to a bar double bar plus b bar. This total is 1 only. This total term is 1 only. B bar, again whole bar. B bar whole bar. A double bar is nothing but A. B double bar is nothing but B. So for this question, correct option, now observe, after simplification here, correct option now. So for this question, A plus B, so right option is, option A is correct answer for this question. Now this is related to the multiplexer dear. Multiplexer. First of all, how to write this answer here? How to write this answer? Y equal to, output y equal to, now S1 may be 0, 0, S1, S0 bar, then I0 input is selected. If it is 0, 1, 0, 1 means 0, 1, 0, 1 means I1 is selected. If 1, 0, 1, 0 means S1, S0 bar, I2 selected. If 1, 1, S1, S0, then I3 selected. Correct. So first of all, what is the I0 value? In the decoder, this A value may for 0 you will get, okay, for both inputs are A only. Here inputs are B, so B only you will get. But inputs are 0 means A bar, 1 means A. Here B input 0 means B bar, 1 means B only directly. So from here I0, I1 value observe. What is S1 value? S1 value is nothing but B. S1 value is nothing but B. S0 value is nothing but A only dear. A. So here substitute here. In this one easily you can substitute here. After substitution, y equal to, come on help me, S1. S1 equal to B bar, S0, A bar, I0 value equal to A bar, A complement, plus S1, B bar, plus A, I1 is nothing but A, plus S1, B, A bar, I2, B bar, plus BC, BA, I3 is nothing but B dear. Now from here clearly observe, there is a multiplexer concept here. Output y equal to A bar, first A bar, B bar, now A, B bar, now B bar 0 only, this term is 0, plus AB only, y B, okay. Now here in this question, now you can take the common B bar, you can take the common, from this to take the B bar common. So output y equal to, if you take the B bar common, A plus A bar plus AB guys. Now here you will get the output y equal to variable plus complement 1 only. So B bar, shall I write B as a B, okay, this B I am writing B complement, again complement, product of A. Anyone help me, this is a formula we have, x plus x complement y equal to x plus y. Variable is complement second variable, so this complement is eliminated. So same only, B bar is x, B bar double bar. So this one we can get B bar plus A dear, that we can also write A plus B bar. So correct option is, what is the correct option now? A plus B bar. Now check this one. So correct option is option C is right answer for this question. This is a question for this one, this is a solution. For this one right answer is option C is correct answer. Yeah, this is a number system related question in the digital. So this type of question compulsory verification is required, options verification is required. So first of all, now this given question, here happily we can write this P0 Okay, now I am writing the next page 10 to the base p plus 100 to the base q equal to 52 to the base of p plus q. Now here tell me, if you move from LSB to MSB, and now dear students, here tell me this is a p power 0, p power 1, q power 0, q power 1, q power 2, correct. This side p plus q power 0, p plus q power 1. Now give the response 0 and something 0, this is only p only, p power 1 into 1 p only, 0 0, okay, directly q square only, equal to tell me 2, p plus q product of 5 plus p plus q power 0, 1 only, 1 into 2, 2 only, correct. Now tell me p plus q square equal to 5p 5q plus 2 dear. Now bring all one side here, one side here. Now if you bring one side, q square 5p p minus 4p minus 5q, okay, minus 2 equal to 0. This is the equation. So verify from the options here. Verify from the option. I am writing same equation in the question paper here only. Now okay, what is the equation now we obtain? q square minus 4p now minus 5q minus 2 equal to 0. So substitute p comma q values, LHS equal to RHS, which is a, okay, substitute here p value 3, let p value 3, q value 7. Now let option C where I am checking. Now q value 7 square minus 4 into p equal to 3 minus 5 into q equal to 7 minus 2. So minus 2, 49. So what happens here? 49 minus 12 minus 35 minus 2, 35 2, 37 plus 2, 12. So 49. So that is a 49 minus 49 equal to 0. You are getting only option C. You can verify from the all options here. From here you can after this verification, option C is correct answer for this question.
Welcome to ACE Engineering Academy and ACE Online. Now we are going to discuss the solutions for pre-GATE for our computer organization and architecture subject. Here, let us start. First question, 1 mark question. Watch question carefully. Read question carefully. If there are P input lines and Q output lines for a decoder that is used to uniquely address a byte addressable XKB RAM. A decoder is used to address a RAM. Its size is XKB, byte addressable memory. Each memory location is used to store only 1 byte. The P plus Q value is 4108. Then X value is, he asked the storage capacity of this one, means memory chip, in kilobytes. Here he mentioned P plus Q value 4108. Try to understand the question clearly first. First of all, for addressing a decoder, number of outputs needed for the decoder must be equal to the number of bytes present in this memory chip. Generally, number of words present in the memory chip. Since it is byte addressable memory, number of bytes present in the memory chip is equal to number of outputs needed for the decoder. Here, output is nothing but Q. That's why number of outputs is nothing but Q. Then number of inputs is given as P. It is nothing but log Q with base 2. Because decoder standard size is n into 2 power n. If its number of outputs is 2 power n, nothing but log 2 power n means log Q. Means here Q plus log Q with base 2. He gave the value 4108. So automatically Q is equal to 4096. When Q is equal to 4096, then P is equal to 12. 4096 plus 12 is nothing but 4108. Here, number of outputs needed for the decoder is 4096. That's why number of bytes present in the memory. Nothing but 4096. That's why it is nothing but 4K. Okay. Now, each memory location capacity is 1 byte. That's why memory storage capacity is 4 KB. 4 KB memory storage capacity. Hence, what is X value here? 4. So, answer is 4. Okay. Come to next question. It is MSQ question. Multiple select question. In the following, the correct statements E/R. First one, CPU uses interrupt priority mechanism when it received the interrupt request input from only one I/O device. It is false. Because interrupt priority mechanism is used when processor has received the interrupt request from 2 or more devices. If only one device is asked the services, then priority is not needed. Processor directly communicates with the device. That's why it is false. Why? Only one I/O device. Processor received the interrupt from only one I/O device. That's why it is false. Non-maskable interrupt is used for finding the hardware failures in a system. Yes, it is true. Because in any system, non-maskable interrupt is used to find power failures, hardware failures. Next, no I/O device is connected for this. Next, non-vectored interrupt pin is used to connect one or more I/O device in a system. It is also true because the hardware interrupts are divided into vectored and non-vectored. One hardware vectored interrupt permits only one I/O device connection, but non-vectored interrupt is used to connect one or more I/O devices. That's why it is also true. One hardware vectored interrupt pin is used to connect multiple I/O devices. False, because if it is vectored interrupt, it permits only one I/O device. That's why here he asked the correct statements. Here correct statements are B, C. If you are having proper knowledge on this, then only you can able to solve this question when you are having proper knowledge on the interrupts. Next, watch this one. Yeah, an 8-way set associative cache memory unit with a capacity of 64 KB is built using block size of 16 words and type of memory used is word addressable and word size is 16-bit. He provided excellent information. It is your responsibility to understand the given information. Here, size of cache memory is nothing but 64 KB. But word size is 2 bytes. Word size is 2 bytes. 16-bit means 2 bytes. That's why number of words present in cache memory, CMW, what it tells? Number of words present in cache memory size by one word size is nothing but 32K, nothing but 2 power 15. Next, the number of words present in main memory is 2 power 32. The number of words, not bytes, number of words present in main memory is 2 power 32. Means MMW is equal to 2 power 32. Here, cache memory and main memory are converted into same units because in the given information, Cache memory is expressed in bytes, but main memory is expressed in words. That's why you have to equalize both. Now, number of words in cache memory is 2 power 15. Number of words in main memory is 2 power 32. Associativity is 8. What is n here? Associativity 8. Then, what he asked here, the number of tag bits needed for each cache line is dash. Tag size is, when main memory and cache memory are expressed in the same units, then from this, you consider what is PA here, physical address size, 32-bit, 32-bit, cache address size, 15-bit. That's why, while finding tag size, PA minus CA plus log n. Here, while using this expression, you should take proper care. Both main memory and cache memory sizes should be expressed in the same units, means number of words or number of bytes. That's why here PA minus CA means 32 minus 15 means 17, plus log 8 means 3 means 20. Answer is 20. Okay. Come to next question. Watch this question carefully. Be dedicated in this. 2 marks question. A CPU word size is 32-bit. Permits only 3 types of instruction formats P, Q and R. Address field size of P, Q and R are 16-bit, 12-bit and 8 bits respectively. In the following, the correct statement C/R means MSQ. Here, instruction code size, entire instruction code size is 32-bit. 3 types of instructions are permitted, P type, Q type, R type. What is the address size of P here? 16-bit, Q here 12-bit, R here 8-bit. Only address sizes are, this means remaining bits are allocated for operation field, means opcode. Here he asked the correct statements. Before going to solve this, first get clarity in this. What is the total size here? 32-bit. So it is divided into look here, very simple and very clear. P type, Q type, R type. Address size of P type is 16-bit. Total size is 32-bit. Here it is 16-bit. It is nothing but address size. Next, 12-bit. It is nothing but address size. Next, 8-bit. It is nothing but address size. Here, what about operation size? Operation size is nothing but, means opcode. Operation means opcode. Look here. Here entire size is 32, means it is 16-bit. Here it is nothing but 20-bit. Here it is nothing but 24-bit. In this, when you are having clarity in this, no problem to solve these questions. If it uses 65,536 number of P-type instructions, not possible to formulate even single Q-type and R-type instructions. Yes, it is true, because number of bits allocated for operation field of P-type is nothing but 16-bit. With 16-bit, maximum number of P-type, maximum number of P-type instructions to be formulated. Is nothing but 2 power 16 only, because out of 32, 16 bits are allocated for this. 2 power 16 means 2 power 6 into 2 power 10 means 65,536. Here, if it uses 65,536 number of p-type instructions, then not possible to formulate even single q-type and r-type instructions. It is true, because all combinations are reserved for all 16-bit combinations. With 16-bit, it is possible to generate 2 power 16 combinations. All combinations are allocated for only this one. That's why option A is true. At the same time, the same thing can be explained in another way. In this, for p-type, here, how many it uses? 65,536 into each operation field requires 16-bit code. That's why 2 power 16 address plus q type into 2 power 12 plus r type into 2 power 8. Here, if you add all these, those must be less than or equal to 2 power 32. Not possible to get more than that one. Here it is nothing but, what about this? It is already 2 power 16. That's why here 2 power 16 and 2 power 16 means 2 power 32. If we use 2 power 16 number of p-type, it is not possible to, here automatically it becomes 0 and 0. Because we take like this. So option A is true. It is true. Next, it is possible to formulate 65,535 number of p-type and 15 number of q-type and 16 number of r-type. Now come here. Out of 65,536, 65,535 are used, means only one free combination is there. That free combination is allocated for next one. In this, each free combination is going to generate how many? Here, this address size is 16-bit. Here, this address size is 12-bit. Difference address is 4-bit. Means, in this case, option B. Number of free combinations is 1. It is used for next q type. So 1 into 2 power a. What is 2 power a? Address difference. What is address difference here? P type requires 16-bit, Q type requires 12-bit. That's why address difference is 4, means 16. Now look here. In these 16, how many it uses? Only 15. Only 15 means, but it uses 16, but it uses 15. Remaining one combination, free combination is allocated for R type. For R type, one free combination is there. Each one is going to generate 2 power a combinations, 2 power a instructions. What is a here? Address difference between this one and this one, again 4-bit. Nothing but 16. That's why it is possible to generate, look here, it is possible to formulate 65,535 number of P type, 15 number of Q type. If we use 16 number of Q type, not possible to formulate even single R type. That's why 15 number of Q type and 16 number of R type. Yes, it is also true. Come to next one. It is possible to formulate 65,535 number of P type, 16 number of Q type and 15 number of R types. It is false, because the reason is very simple and very clear. If it uses 65,535 number of P type, number of free combinations is only 1. Then here it is possible to formulate maximum 16 Q type. If it uses 16 Q type, no free combination is allocated for next R type. That's why option B is true, but option C is false, because it uses 16 number of Q type. That's why it is false. Come to D. It is possible to formulate 65,534 number of P type, 30 number of Q type and 32 number of R-type instructions. It is true because in this P-type 65,534 means number of recombinations 2. Number of recombinations left for next size. Each one generates then maximum Q-type, then maximum Q-type. Each free combination is going to generate 2 power 4 additional opcodes. 2 power 4 additional opcodes, address difference is 4-bit for Q-type, but 2 free combinations are there. 2 into 2 power 4 means 32. But out of 32, how many it uses? How many it uses? Only 30 means number of recombinations allocated for next R-type is 2. But it uses only 30. Next, remaining 2 free combinations are allocated for R-type. So for R-type maximum how many? 2 into each free combination is going to generate again 2 power 4 because address difference between these two is 4-bit. That's why it is nothing but 32. So option D 100% correct. So in this, finally correct options are A, B, D. Watch this question. A processor has 35 distinct instructions, means it permits 35 distinct operations, and X number of general purpose registers. Number of general purpose registers given is X, means you have to find X value. A 32-bit instruction word has an operation field, 2 register operands, and an immediate value, means immediate operand value. The smallest value to be produced in the immediate field is minus 32,768, and operand is expressed in signed 2's complement notation. Operand is not unsigned, it is expressed in signed 2's complement notation. Smallest value to be produced here is minus 32,768. It is the negative value, smallest. The maximum value of X is dash. He asked for the maximum number of processing registers fabricated in the processor. Here, if you understood the question, no problem to get solution. First, watch this one. Here, what is first one? Operation, also known as opcode. 2 registers. Here, RD, RS, IV. What is the total size? He mentioned total size is nothing but 32-bit. Here it permits 35 instructions, means log 35. Number of bits needed for operation field is nothing but 5 bits are not enough, that's why 6 bits are needed. At the same time, immediate value. In signed 2's complement notation, the n-bit range, nothing but minus 2 power n minus 1, 2 plus 2 power n minus 1 whole minus 1. It is the smallest value. It is the smallest value. So for this, what is the smallest value to be produced here? Minus 2 power 15. Because minus 2 power 15 value is nothing but minus 32,768. That's why here n value is not 15, n value is nothing but 16, because n minus 1 is 15, n value is 16. That's why, what about the size of this one? 16 bits are needed. So out of 32, 16 bits are allocated for immediate value, 6 bits are allocated for operation, means 22 bits are consumed. So remaining 10 bits are allocated for these two register fields. That's why here 5-bit and here 5-bit. With 5-bit, maximum number of GPRs to be addressed. GPR means general purpose registers. Nothing but 32. Maximum number of GPR means general purpose registers to be addressed. With 5-bit is nothing but 32. So what about our answer? 32. Okay, next. Go for next question. Read question properly. It is also MSQ question. Multiple select question. How you conclude? In the following, the correct statements E/R. That's why it is MSQ. Watch question carefully. Consider a 3-word instruction. Word size is, consider a 3-word instruction. Instruction size is 3-word. Instruction size is equal to 3-word. Okay, next. What is the given instruction? Given instruction is sub 255 bracket of R1 at the rate of 7500. What sub tells? Operation at the same time. Where R1 is an index register, what is R1 here? Index register. Next, 255 is the offset used for generating effective address with R1. Here, if it is indexed addressing mode, what is effective address here? In indexed addressing mode. Effective address is nothing but offset plus given register nothing but R1, where it goes to MAR, means to read the operand, one memory cycle is needed. One memory cycle is needed to read which operand? First operand. What is first operand here? To perform subtraction operation. To perform subtraction operation, it gives the first operand and it gives the second operand. Okay, look here. Here, what is 7500? Memory address. It is nothing but memory address. At the rate symbol indicates indirect addressing mode, means at the rate 7500 means 7500 provides the not operand, effective address, because it is memory indirect addressing mode. To read that effective address, it requires one memory visit. Immediately that effective address is again placed on address bus. Why? To read the second operand, that is to read second operand. CPU requires 2 memory cycles. Why 2 memory cycles? One memory cycle is used to get the effective address. Second memory cycle is used to read the operand from that address. Next, first here, to read this one memory visit is needed. To read this operand from this, 2 memory visits are needed. To read only 2 operands, we require 3 memory cycles. Later, what he mentioned, During execute cycle, the CPU reads the data from the address generated by 255 bracket of R1 means first operand. Next, at the rate of 7500 means second operand, and saves the result in the address generated by 255 bracket of R1 means what he mentioned. After reading the data from this address and this address, subtraction operation is performed in ALU. Later, that result is again stored here. To store the result here, one more memory cycle is needed. Suppose if system wants to store the result here, two more memory cycles are needed, but he mentioned only here it is the destination address for storing the result. No interrupt cycle is occurred during execution, and instruction cycle is filled with both fetch and execute cycles. Instruction cycle means fetch cycle and execute cycle. Look here. To save data means to store data. Data means result, final result. At where? At where? First operand means here 255 bracket of R1 address. CPU requires one more memory cycle. Okay. Now, in our style, look here. What is instruction cycle? Instruction cycle is the combination of fetch and execute cycles. In fetch cycle, what happened? Just instruction fetching, later decoding. Remaining all operations are performed in execute cycle. Size of the instruction is 3 word. Size of the instruction is 3 word. Means processor can fetch only 1 word at a time because word size is nothing but data bus size. That's why fetch cycle requires 3 memory cycles. Why? To fetch 3 words. 3 memory cycles are needed for this. Needed to fetch 3 words. After that, come to execute cycle. First of all, 1 memory cycle is needed to read the first operand. Next, 2 memory cycles are needed to read the second operand, and 1 more memory cycle is needed to read the third, to write the third operand. Look here. 1 memory cycle is needed to read the first operand. 2 memory cycles are needed to read the second operand. After that, operation is performed. To store the final result, it requires 1 more memory visit. These 2 are used for operand reading, and it is used for result writing. Means in execute cycle, total number of memory cycles needed is 4. It is our basic information. Come to question now. In the following, the correct statements E/R. Only one fetch cycle requires 3 memory visits. Only fetch cycle requires 3 memory visits. Yes. Only fetch cycle requires 3 memory visits. Yes. Okay. Fetching means process of reading the instruction code from memory, later decoding, that's all. It is correct. What about next one? Only execute cycle requires 3 memory visits. No, it is false because execute cycle requires how many memory visits? Not 3, 4. Next, instruction cycle requires 4 memory visits. Instruction cycle requires 7 memory visits. 3 plus 4. 3 plus 4. Here, 3 plus 4, how many? 7. That's why option C is also false. Come to D. Instruction cycle requires 7 memory visits. Yes. So correct options are A. Thank you and all the best.
So look at this question. This question based on static scope and dynamic scope. So if you have idea about static scope rules and dynamic scope rules, you can easily solve this problem. Here I didn't provide complete program. You can consider it as a part of the program, right friends? Okay. Just look at here. There is a function f. Let me write here. There is a function f we declared. So it is a definition of function f, friends. Okay. It's a function definition. So there is a function f defined here. Under function f, there is another function g also defined. Is it clear, friends? Outside I am calling function g. It means that something like main is maybe invoking g function. You can consider like that. Okay. So the moment if I call g function, then control will be transferred to g. Right, friends? Control will be transferred to g. Then it is taking int x is equals 20. Okay. Here we are having int x is equals to 20. Afterwards it is calling function f. So with that call, control enter into function body f. Clear, friends? Okay. So inside f we are having statement is called print x. Print x. Here global variable x also available. Int x is equals to 10. Now what is the difference in static scope and dynamic scope here? Okay. In static scope, whenever we are going to print the value of x, okay, first it is looking for local variable x. If local variable x is not available, it is looking at ancestor variables. Okay, ancestor variables. For example, if you draw the tree structure for this program, the tree structure was looking like this. There are some global variables are available. Okay, there are some global variables are available. Global variable. Under global variable, we define two independent procedures. One is called f, another one is called g procedure. Right, friends? Okay. Under procedure f or under function f, we are having statement is called print x. Print x. We have one statement is called print x. Right, friends? Okay. Here inside there is a local variable x whose value is equal to 20. And afterwards we are having function call. Here there is a global variable x is equals to 10. If you recall the concept of static scope, dynamic scope which I explained in the class, whenever we are asking print x, it is checking for local variable x first. If local variable x is not available, it is taking ancestor variable. So therefore, who is ancestor for f means obviously the global variable. Therefore, static scope it is printing value is equals to 10. Static scope it is printing value equal to 10. Is it clear, friends? Okay. Suppose if you apply dynamic scope is always taking function call in sequence order. Okay. If you look at here, friends, the function call in sequence is first g is calling f. G is calling f. Is it correct? Inside g we have local variable x is equals to 20. But control flow point of view, control flow starting from global variable, assume that global variable x also available here. Okay. Control flow starting from global variable x is equals to 10. So from global variable to it is calling, it is entering into g function. From g function it is calling f. But inside f there is a statement is called print x. Print x. So whenever if you want to print the value of x locally, first it is searching for local variable x. But there is no local variable x. When control is at f, these are called active subprograms. Active subprograms. So whenever local variable is not available, it is taking most recent active subprogram variable. This is active subprogram whose value is equals to 10. Okay. So therefore, dynamic scope answer is equals to 20, friends. Okay. So static scope answer is 10 and dynamic scope answer is 20. In a simple word, static scope is working like a C programming only. In C programming, if local variable is not available, it is taking global variable. Where dynamic scoping, it is always taking value from the point of invocation. Point of invocation means, for example, from here we are calling function. Therefore, control enter into this function body. First, if you want to search for x, if there is no local variable x, so the point of invocation is this is the place. Here we are checking for x. Here also it is not available, it will go to global variable. This is called dynamic scoping. Okay. Look at here, function f calls g and g calls h. See, these kind of programs in the recent years in the GATE paper, they are drawing one recursion tree. They are drawing one recursion tree and they are asking question based on recursion tree, friends. Okay. So that's the reason we prepared questions like this. A function f calls g and g calls h. At the deepest point of execution, how many activation records are present on the runtime stack. You know, whenever function f is calling g and g is calling h, you know, every function call must be loaded into stack. Therefore, whenever I call function f activation record load into stack, and the moment when it control enter into here, g activation record load into stack. When it is enter into here, h activation record also load into stack. Therefore, at the deepest point of view, runtime stack having how many means 3 activation records. So actually, this question has given to test the psychology of the student. Generally, this question is very simple. So students, when they are evaluating problem in the exam, they think that this question is very simple. Will they ask question like that? Means even though they know the answer, they will think like that whether 3 is correct or not. Because last year in the exam, they provided some questions like 60, 50, not 60, 50. Sorry, let me consider. So they provided 10, 20, 30, 40, 50, 60. So in the gate paper, last year gate paper, they asked question like this: if the input array elements are in this order, and if I choose last element as a pivot element, and if you apply quicksort algorithm, how many minimum number of swaps are required? See, by looking at that problem, you can say swaps are not required, you can say 0. But psychologically, student point of view, you will think like how it is possible to ask this is easy question in the exam like that, okay? So therefore, to test the psychology of the student, we gave this question, friends. Please understand 3 is the correct answer. Next, how many static or lexical parent links does the activation record R can contain? Look at here, these functions within P we define Q, within Q we defined R. You know, in static scope, just look at friends. So under P we defined Q, under Q we defined R. Suppose if you want to search any variable, whether it is present or not in the R, it is searching first locally. It is searching first locally, friends, okay? If it is not available, then it is searching its ancestor. Here also it is not available, it is searching in its another ancestor. So therefore, if you want to create static links or access links, what you have to do? Simply you can create a stack. You can create a stack. First P is calling suppose Q, and Q is calling something like R. Right, friends? If you want to search any value or any variable inside R, it is looking locally first. If locally not available, it is using static link, it is entering to Q block. Suppose here also it is not available, then it is using static link, it is entering to P block. Here also it is not available, we can say that symbol is undefined symbol. So if you want to search any variable local to R function, first search in R. If it is not available, search in Q. If it is not available, search in P. So that is called static scope. Static scope says that referencing environment of any variable resolved by giving preference to local variable. If local variable is not available, it is giving preference to most recent ancestor variable. Who is the most recent ancestor variable means Q. Here also it is not available, to go to another ancestor variable. Okay. Therefore, number of links for this one is equals to 2, friends. Okay. 2 is the correct answer. Clear? These are the keys which are inserted. So these are the keys which are inserted into empty binary search tree in this order. Clear, friends? Okay. So let us consider empty binary search tree, and we have to insert keys in this order. You know what is the meaning of binary search tree and all, so we don't want to discuss definition here. So first I can insert 15. Afterwards, to insert 10, 10 is going to compare with 15. 10 is less than 15, so therefore it should be the left side. Next 20, 20 is right of 15. 20 is right of 15, because in binary search tree, for every key, left subtree values are less than that key and right subtree values greater than that key. Next afterwards 8. 8 is left of 15 and left of 10. This is a place we can insert 8. The next 12. So 12 we can take left of 15, right of 10. Right of 10. Next one is 17. 17 is right of 15 and left of 20. 25 is right of 15 and right of 20. right of 20. Is it clear? So now they are asking the height of BST is defined as the number of edges on the longest route to leaf path. This kind of questions are asked in the PYQ papers also. So that's why we have taken same model type questions now. So which of the following statement is true? So the root of BST is 15. Yes, of course, root of BST is 15, which is correct. Okay. Next one, the height of BST is 2. Height means longest path from root to leaf node. So that is equals to longest path. We can take any leaf node 2. So second option also correct. The longest route to leaf path is 15, 10, 8. If you consider 15, 10, 8. Of course, many other paths are also possible. This is also known as longest path. The height of BST is 3, which is not correct, friends. Okay, which is not correct. So therefore, option A, B, C are correct for this question. Okay, A, B, C are correct answers. So this question based on Q concept, general operation, NQ and DQ operation. Because in the recent year GATE paper, they asked same models. Of course, I have taken very simple question in this case. But if you see PYQ question 2023, 2024, they ask only based on NQ and DQ operation question, friends. Okay. We'll follow the pattern. See, whenever Q is empty, just consider there is a Q. Whenever Q is empty, front pointer point into -1, a rear pointer also point into -1. Assume that this Q is implemented by using array whose index is starting from 0. Okay, whose index is starting from 0. Next, perform the following operations. Perform the following operations. Just look at first operation. NQ of 10. You know how to perform NQ operation. So while performing NQ operation, 2 points you have to recall. So first one is, if you want to insert an element into empty queue, clearly it is empty queue, right friends? To insert element in empty queue, first increment rear pointer by 1, -1 plus 1 that equal to 0. So at 0th index you have to insert the element. Okay. So to insert element, if you take name of the queue is Q, assume that name of this queue is Q, and Q of R is equals to insert the element. So what is the element they are going to insert? 10. Okay. We have to insert a 10. Remember, it is the first element to be inserted in the queue. The moment first element inserted, we need to update front pointer as well. Okay, front pointer also point into 0th index. It is the case only if you want to insert element into empty queue. If it is non-empty queue, no need to update front pointer. Okay, so therefore 20 inserted into queue, friends. 20 inserted into queue. Let me increase the speed. Sorry, not 20, 10. Please excuse me. So this value is 10. 10 inserted into queue. Next, second one is NQ. 2 times NQ. So simply I can increment rear pointer by 1. I can insert 20. Again I can increment rear pointer by 1. I can insert 30. See, whenever I insert empty queue, I update the front pointer. But remaining cases I am not updating front pointers. Okay. Next, DQ. Deletion always happens through the front pointer. So wherever front is pointing, that element we have to delete. After deleting, increment front pointer by 1. Front pointer by 1. Suppose if you have only one element in the queue, if you want to delete that element, make front equal rear equal -1. But you have more than one element, right? That's why delete at 0th index element, afterwards increment front pointer. Next, NQ 4 times. 1, 2, 3, 4 times. Okay. So 4 times you increase 40, 50, 60, 70. So third index 40. Right friends. Okay. Fourth index 50. Fifth index 60, sixth index which is 70, right friends. Okay, then what is the value at the front of the queue? Of course, at the front of the queue we are having value is equals to 20. Here I explain only simple concept NQ and DQ operations. But if you observe PYQ questions 2023, 2024, same model questions only they are asking. Okay, please do practice like this. So it is a linked list based question. So assuming that this node is available at address is 100, this node available at address is 200, let it be 300, and it is 400. Right friends, 400 link pointer is null. Now suppose there is a pointer P which is pointing to the node with value is equal to 20. Means right now P is pointing to the value 20. It means that you can imagine P is holding address is equals to 200. With this address 200 is pointing to 20. Is it clear, friends? Because 20 is having address is 200. Now after executing this statement, what is this statement? Let me rewrite here. P arrow next is equals to P arrow next, again arrow next. Remember, left side is a placeholder where that right side value evaluated, that is copied into P arrow next. Right now what is P pointing? 200. 200 arrow next. See here, it is 200. 200 data is 20 and 200 next means 300. Remember, node must have two members, okay? So just let me recap once again node structure. Suppose if you take struct node, which contains two members, one is called data, another one is next. Next is a pointer pointing to node data type. Node is not existing, that's why I'm using keyword is called struct, like this. It means that each node contains two members, data member and a link member, that is next member, okay? So therefore 200 next is nothing but 300, friends, okay? 200 next is nothing but 300. You can imagine. So let me draw. For example, you can consider like this, okay? Here we are having 200, it is 300, afterwards it is 400, right, friends, okay? So of course we are having 20 here, it is 30 and it is 40, which is pointing to null. Is it clear, friends? It is holding address is 400, it is holding address is equals to 300. I am not showing first node, okay, because there is no space, that's why I am not showing first node. Please understand, one more node is also existing here. Now right now P is pointing to where? 200 location. So P is pointing to 200. So 200 next is nothing but 300. So therefore 200 arrow next, that equal 300. Right, friends, okay? Now 300 arrow next. 300 arrow next is equal to 400. 400. That will be copied into where? That will be copied into P arrow next. P right now how much? 200. So 200 next updated with 400. Okay. So therefore this is 200 next, it is updated with 400. That means this link is modified, it is pointing this location. So the moment this link get modified, even though this node is there physically, so logically it is meaningless. We have to ignore it. Therefore now they are asking what is the resulting list. Obviously what is starting node? Starting node is 10. So here one node is there, 10, which is pointing in 200 location, it is starting address, okay? 10, 20, 40 and then null. Is it clear, friends, okay? So 10, 20, 40 null. So therefore answer to this question is option A is the correct answer. So what is the expression they are asking this problem? So here they provided postfix notation. So there are certain rules to evaluate postfix notation, friends, okay? So I will take help of stack so that you can understand. See, just examine the sequence, it is an operand. Whenever you see the operand, create a node, copy that operand, push node address into stack. It means you can visualize like this, stack contains element is 6. Again you observe operand, create a node, copy that operand, push node address into stack. Now stack contains elements are 6 and then 2. Okay. Next one is 3, create a node, copy that address, push node address into stack. So we are having 6, 2 and then 3. Is it clear, friends? Okay. Next one is operator. See, the moment if you see the operator, since it's a postfix notation, you have to perform two pop operations. First pop operation SN as a right child, second pop operation SN as a left child. The result 2 plus 3, 5 must be pushed into the stack. Okay. So therefore the stack contains elements are 6 and then 5. Right, friends, okay. Next one we are having minus. Since it is operator, when you see operator, perform two pop operation. First pop operation is SN as a right child. Second pop operation SN as a left child. Push node address into stack. then stack contains 6 minus 5, that equals to 1. Right friends, okay. Next one, there are 3 operands, create a node and copy those operands, push them into the stack. Is it clear friends, okay? Same concept, that is the reason I am not speaking anything. That's it, okay. Afterwards we are having division operator. So when you observe division operator, perform first pop operation, Sn as a right child, perform second pop operation, Sn as a left child, 8 divides 2, that equals to 4 friends, okay. So therefore the result is 1, 3, 4. Afterwards addition operator, okay. You take addition operator, sorry, yes, it's addition operator. Since it is addition operator, perform 2 pop operations, whose value is equal to how much? That is division 8 and then 2. And second pop operation, that is 3. Right friends, okay. It means we divided, we have taken 4 and then 3. So result is equals to 1. Clear friends, okay. So this result is 4 plus 3, that equal to 7. 1 comma 7. Push node address into stack. Next we are having star operation. Whenever it is star operation, perform 2 pop operations. It is a first pop operation, Sn as a right child, that equal to plus 3, 8 divides 2. Right friends, okay. And second pop operation, you can take this one. Right friends, okay. So it is Sn as a left child. So it means that you are pop out this one, 1 and 7. So 7 into 1, obviously result is equals to. So here we are having this value, this total value equal to 7, and earlier we are having 1. So 1 into 7, result equal to 7. So therefore, answer this question is 7. If you want to verify it is correct or not, just apply postfix notation or post order traversal. If you get same expression tree, then it is correct answer, okay. So 7 is a correct answer friends. There is a hash table of size 10 uses h of k equal to k mod 10, and key inserted in this order, right friends, okay. Collisions are resolved by using linear probing technique. And what is index value? Index where the key 27 is stored. So what you have to do, first substitute 23 in this function. So h of 23 is equals to 23 mod 10. It is hash into third index. It is hash into third index. Whereas in the hash table, we are having index and then key values. So since hash table size is 10, therefore index is starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and I can say 9 also. Clear friends, 9. So clearly this 23 is hashing to third index. So this is a place where 23 is hashing. Right friends, okay. After 43 mod 10 also hashing to third index. But in linear probing, if third index is not free, then go to next index. Go to next index, okay. Next 13 mod 10, third index. Third index already having key element. In linear probing, if third index occupied, then go to fourth index. If fourth index also occupied, you can go to next index, that is fifth index, that equal 13. Right friends. Now 27, obviously it is seventh index. So directly I can store 27 at the seventh index only. So they are asking 27, so therefore 27. The reason why I had taken this question linear probing means there are so many questions asked in linear probing concept friends, okay. So therefore I had taken one example for linear probing to remember the revision concept point of view friends, okay. Look at the first question. This question based on master theorem. So whenever you see recurrence equation in this format, compare that equation with the given standard master theorem equation, which is in the form of a into t of n by b plus theta of n to the power of k into log to the power of p n base b, right? So get the values of a, b, k, p from the given problem. In this case, a is equals to h, b is equals to 2, where k is nothing but n to the power of k value equals to 2, where p value is absent here, log to the power of 0 n, so p value is absent. So therefore, I have taken a, b, k and then p. In the classroom, we discussed master theorem 3 different cases. So first case is a greater than b to the power of k. I am checking a greater than b to the power of k is available or not. Okay. So where a is nothing but h and b is nothing but 2, k value equal to, yes, a greater than b to the power of k condition satisfied. Right friends. If the condition satisfied, the formula theta of n to the power of log 8 to the base b, a means 8 here, log 8 base 2 we can write n cube. So therefore answer to this question is theta of n cube, friends. Right? Yeah. This question, generally in greedy method, while we are discussing Prim's algorithm, Kruskal's algorithm, we solve some questions based on graphs, right? Okay. So with that basic concepts, you can solve this problem. But of course, it is not easy problem, friends. Okay. So it is one area, I can say untapped area so far. Maybe this year I'm expecting this type of questions, friends. Okay. See here, they mentioned there is a simple graph. You know what is the meaning of simple graph? There are no parallel edges, there are no self loops, right, friends? Okay. So simple graph with how many vertices? 6 labeled vertices, where each of the possible edges included independently with the probability is 1 by 2. So probability is 1 by 2 means between every pair of vertices there exists an edge. That edge may be present or may be absent. Is it clear, friends? Okay. So out of 2 possibilities, only one possibility will exist. Either it may be present or absent. Is it clear? So what I am trying to say, the meaning of this statement, for example, V1 and V2, there are 2 vertices are there, friends. Okay. In order to make it a graph, there are 2 possible ways you can make it graph. One is there is no edge between V1 and V2. That is one possibility. Or else other possibility is I can take V1, V2, I can connect these 2. Clear, friends? Okay. If edge is present, we can say it is 1. If edge is absent, we can say it is 0. Means there is no edge present between V1 and V2. Therefore, between every pair of vertices V1, V2, there are 2 possibilities. Either edge is absent or edge may be present. There are 2 possibilities. Is it clear, friends? Okay. Alright. Next one. What is the probability that the resulting graph connected but not a tree? You should understand some basic concepts here, friends. Okay. What is the meaning of tree? Tree also connected, but it is acyclic. Means there is no cycle in the tree. There is no cycle in the tree. It means they are asking, they want connected graphs, okay, which are forming cycles, because they are saying connected but not tree, right? Means they want connected graphs which are forming cycles also, right? So this problem based on some standard formulas, friends, you have to remember this formula, okay? Just look at here. Since there are provided 6 vertices, so in order to get max number of edges, we have one formula, friends, okay? Generally, if you take a complete graph with n vertices, we have n into n minus 1 by 2 edges. So total number of edges in complete graph means NC2. That is a maximum possible number of edges in simple graph. Is it clear? Just remember, in a simple graph, maximum number of possible edges are there is nothing but NC2. That is n into n minus 1 by 2. Here they provide 6 vertices. Therefore, maximum number of possible edges are 6C2. That equal to 15 edges are possible. 15 edges. Now by using these 15 edges, how many graphs are possible? How many graphs are possible means, as I mentioned in the beginning, each edge is having 2 possibilities. Either it may be present or it may be absent. For example, if I have some variables like this, x1 is a variable and x2 is a variable, each variable having 2 possibilities, 0 or 1, 0 or 1, then total how many possibilities are there? So we have like 0, 0, 0, 1, 1, 0, 1, 1. Total 4 possibilities are there. This 4 we can write it as base indicates that number of possibilities, and exponent indicates that number of such variables. Suppose for example, if you have 3 variables, then each variable having 2 possibilities, then number of variables are 3, 2 power 3. That means 8 possibilities are there. 8 possibilities I can say all are zeros, 0, 1, 0, 1, 0, 0, 1, 1, 0. Like that we can end it with all are ones. If you understand that basic idea of this problem, very simple. Since there are 15 edges are there, 15 edges. For example, if I name those edges are something like E1, E2 up to so on E15, 15 edges are there. Then each edge is having two possibilities. It may be present in the graph or it may be absent in the graph. Therefore, there are two possibilities, either present or absent like this. Since there are two possibilities, that's why I written base is equal to 2. But how many such variables are there? 15. That's why 15. Therefore, total number of graphs by using 15 edges are 32,768 graphs are possible. Total number of graphs are 32,768. These are standard formulas, friends. You have to remember. Not standard, simply you can think logically. So, total number of graphs means each edge is having two possibilities, either present or absent. Total we are having how many edges are present? 15 edges are there. Therefore, 2 power 15. These many graphs are there. But what type of graphs they ask in this question? They want connected and also they are forming cycle. Connected and cycle graphs they are asking. So, in that case, friends, total number of graphs we understood, right? Now, suppose I am taking Cn is equals to number of connected labeled graphs. Number of connected labeled graphs. You please remember this formula, we will discuss later. Okay. This indicates connected label graphs. From these connected label graphs, if I subtract trees, then I can say number of connected graphs which are not trees, right? But how to find trees? There is a formula for trees, friends. Okay. If there are v vertices are there, total number of trees are possible equal to v to the power of v minus 2. In the spanning tree concept in the class notes, I explained clearly. If it is a complete graph, is it clear, friends? If it is a complete graph with n vertices, then total number of trees possible. If it is a complete graph with v vertices, total number of trees are possible v to the power of v minus 2. Here there are 6 vertices are there. So 6 to the power of 6 minus 2, that equal to 1296 trees are possible. Is it clear, friends? 1296 trees are possible. Just look at this problem once again. You understood, right? Okay. These are total number of graphs. These are total number of trees. We have one formula, that is number of connected graphs. Connected label graphs. You have to remember this one, friends. Okay. From the total number of graphs, which I have written here is the total number of graphs, you have to subtract number of disconnected graphs. Okay. So it is compulsory you have to remember this formula, because it's not the right time to discuss this formula. This formula for what purpose? Number of disconnected graphs. Okay. From the total number of graphs, if I subtract number of disconnected graphs, then you will get total number of connected graphs. So total number of connected graphs, how we are going to do in the short period of time in the exam means, you have to remember like this. See, for n is equals to 1, Cn value equal to 1. For n is equal to Cn value equal to 1. Like that, if you compute up to 6, so n is equal to 6, C6 equals 6064. If you could remember this part, then it is easy to solve the problem. So I can compute this value within 30 seconds, right, friends? Afterwards, anyway, I know this value and I can remember the C6 value, right? Within 10 seconds, I can compute the difference. So 30 plus 10, 40 seconds over, right, friends? Okay. The number of trees, it is direct formula, right, friends? It takes another 5 to 10 seconds. Then after getting number of trees, now see here, connected but not trees. You understood that connected graphs and you understood these are trees. If you subtract, then we will get connected but not trees. That equal to 25408. Maybe problem seems to be lengthy, but if you already practice this kind of problems by remembering Cn values up to at least 6, I believe that in the exam they don't ask up to 6 vertices, friend. Maybe they will ask up to 4 vertices, maximum 4 vertices. Okay. So therefore, 25408 by 32768, by simplifying you will get 1588 by 2048. So you can solve this type of questions only if you remember these values before entering the exam hall, friends. Okay. So these kind of questions I am expecting this time, because they combine probability in the graph theory with the spanning tree concepts here. Okay. Very nice question it is. So what is the answer now? So answer is C is the answer. But my advice is you remember this one. This indicates number of disconnected graphs. Okay. It indicates total number of graphs. From total number of graphs, you are subtracting number of disconnected graphs. We are getting number of connected graphs. right friends? Okay, from the number of connected graphs we are subtracting trees. Okay, sorry, we are subtracting from the total number of graphs, we are subtracting disconnected graph, we are getting total number of connected graphs. From the total number of connected graphs, we are subtracting trees. Then these are connected but not trees. The probability that they are connected but not trees means these numerator indicates favorable cases, denominator indicates total number of cases. I hope you understood, right friends? Okay, this is one important problem, you can remember this. Yeah, this is asking about length of the longest common subsequence. You try to remember the formula for length of the longest common subsequence which I explained in the class. Suppose if x is a sequence having length is equals to m, and y is a sequence having length is equals to n. For example, x sequence starting with 0 index 1, 2, 3 up to so on m minus 1. Here we are having some elements like whatever it may be a, b, c up to so on something like a. Is it clear friends? Okay, and y is a sequence starting index 0, 1, 2, 3 up to so on something like n minus 1. Clear friends? Okay, here we can say b a b up to so on something like a. If two sequence if they provide, then we can create formula if either m is equals to 0 or n is equals to 0 or both m is equals to n is equals to 0. Clear friends? Both m is equal n is equal to 0. In that case, length of the longest common subsequence between these two sequences must be equal to 0. Is it clear friends? Length of the longest common subsequence between these two sequences must be 0. Suppose if the last character is matching, as in that last character, we can indicate that x of m minus 1 is equals to y of n minus 1. The last character is matching, then we can say one character is matching, then ignore that character, then another sequence length is m minus 1 and second sequence length is n minus 1. Between these two, we can find length of longest common subsequence. It is the case if the last character is matching. Suppose if the last character is not matching, x of m minus 1 not equals to y of n minus 1. If it is not matching, in that case, what you have to take? You can take maximum of length of longest common subsequence m comma n minus 1, length of longest common subsequence m minus 1 comma n. That's all. Is it clear friends? Okay. So while computing L of m comma n, I explained simple logic in the class. Please recall that logic. For example friends, if you want to find this value, so how we are getting this value means this value depends on these three values friends. Okay, these three values. Suppose for example, if the character is matching, we can write 1 plus its diagonal element. So that is the meaning of this statement, 1 plus its diagonal element. I will show in the table also. If the character is matching, this length is equals to 1 plus diagonal element. Suppose if the character is not matching, then so you have to look at top side, you have to look at left side. Between these two, you can take max value. I will explain by taking example. Look at here friends. Suppose for example, the sequence length, when it starts here, sequence length becomes 1 because one character is there, right? One character. And by the time it reaches its sequence length is 2, by the time it reaches sequence length is 3, 4, 5, 6, 7. It is sequence length they provided. Similarly, here sequence length is 1. When it reaches G, sequence length is 2. It is 3, 4, 5. When it reaches here, sequence length equal to 6. Now at this point of time, there is no character, that's a sequence length is 0. Here also there is no character, sequence length is 0. Right friends? You can imagine these values are m values, whatever I written here. Okay, m values, like these are m values. Is it clear friends? These are m values. And similarly, these are n values friends. So whatever I have written, these are n values. Okay. This last row, rightmost column indicates that length of the longest common subsequence. one sequence having length is 6, another sequence having length is 7. Do you know how we are getting this answer is 4? Very simple, as I explained earlier. If one sequence length is 0, then obviously common subsequence length is 0. Right friends? Even if it is n is 0, we have to keep this value is 0. Right friends? So filling this table, it doesn't take much time. Maybe in the explanation it is taking time here. It takes hardly 1.5 minutes, not more than that friends, okay? How we are going to fill this one? So verify A and G are matching? No. If they are not matching, you can look at top side, you can look at left side. Between these two, you can take max value. So here top value is 0, left value is 0. Between these two, max means 0 only. Right friends? Similarly, A and X are not matching, same concept we are explaining. If they are not matching, we can look at top side, you can look at left side. Between these two, you can take max value. Suppose if you take A and it is A, matching, right? Then 1 plus, you can take diagonal value. So diagonal value is 0. 1 plus 0, 1. So like that, we can fill up this one also. Here, A and Y are not matching. If they are not matching, look at left side, look at top side. So left side is max value. I'm taking max value only. Okay. Now to find this value, friends, look at left side, look at top side. Max value is left side. That's why I'm taking 1. So simple logic, if the character is matching, then you can take 1 plus diagonal element. If the character is not matching, look at top side and look at left side. Between these two, you can take max value. If you do that process, at the end you will get max length is equal to 4. You can refer the class notes as well, okay? Next, this question based on the properties of minimum cost spanning tree. Right friends? See, they mentioned distinct positive edge weights. If a constant alpha is added to every edge weight, for every edge weight a constant alpha is added. For example, if you consider, just look at here, suppose I'm taking it is 10, it is 20, let it be 40. So let it be V1, V2, V3. Clear friends? V1, V2, V3. In this problem, look at first option. The minimum spanning tree of G remains same, they are asking. See, whenever a constant value is increased, constant value, suppose for example, I'm taking alpha is equal to something like 50 for uniformity purpose. Okay. As a result of adding 50, so 10 plus 50 is 60, 20 plus 50 is 70, and 40 plus 50 is 90. I can say it is V1, it is V2, it is V3. Clear friends, okay? Now what did I mention? The minimum spanning tree of G remains same. So earlier, what is the minimum cost spanning tree? If you apply Prim's algorithm or Kruskal's algorithm, let us take Kruskal's algorithm. In Kruskal's algorithm, edges must be included in the increasing order of their weights. So first I can include 10, afterwards I can include 20. Here also I can include first 60 and here 70. That's why minimum cost spanning tree remains same only. Okay, so first one is correct. The shortest path between all pairs of vertices remain unchanged. No friends. For example, if I ask shortest path between V1 to V3, if I ask shortest path V1 to V3, what is shortest path from V1 to V3? If I use this path, it is 40. If I use this one, it is taking 30. Right friends, okay? So shortest path from V1 to V3 is V1 to V2, V2 to V3. The total cost is equals to how much? 30. Shortest path V1 to V2 like this, okay? But as a result of increase adding 50, here 60 plus 70, 130, but it is only 90, right? The shortest path only V1 to V3. Earlier V1 to V2, V1 to V2, V2 to V3. This time V1 to V3. That is the reason it is not correct. The relative ordering of edge weights remains unchanged. Yes, relative order of edge weights remains unchanged, friends, okay? Relative order of edge weights remains unchanged. Relative order means like the order, whatever you are taking, 10, 20, 40, here also same order, okay? Next, the total weight of the MST increased by, because you increased alpha weight, you know MST contains V minus 1 edges. Every MST contains V minus 1 edges. Every edge weight is increased by alpha, the total weight increased by alpha into V minus 1, which is also correct. Is it clear, friends? Okay. Therefore, A, C, D are correct answers. So this is a knapsack problem. They provided, you can consider it is weight W1, it is profit P1. So W2, profit P2, W3, profit P3, W4, profit P4. Okay. So it is a 0-1, it is a knapsack problem. You please kindly refer greedy method as well as dynamic programming knapsack problem. In the greedy method, what we have to do, we have to find the value to weight ratio or unit weight profits. So what is the meaning of unit weight profits? We can compute P1 by W1, P2 by W2, P3 by W3, P4 by W4. After computing, you have to arrange the decreasing order. So if I arrange the decreasing order, first I can take 12. Just look at friends, okay. You know that P4 by W4 value greater than or equals to, next P1 by W1 greater than or equals to, next P3 by W3 greater than or equals to P2 by W2. Just arrange the decreasing order friends, okay. Right, after arranging, you have to place objects in this order. So it is nothing but fourth object, right. What is the fourth object weight here? Fourth object weight is 2 and profit is equals to 24. Therefore, if you take total profit, I can place fourth object completely into the knapsack, where knapsack having weight is equals to how much? 11. Is it clear friends? Knapsack is having weight is equals to 11. Capacity is 11. Now if I place fourth object 4 into the knapsack, then it occupies 2 gram space or 2 unit space, and profit you are getting 24. Okay. So 24 is a profit by placing fourth object. Now how much remains space in the knapsack means 9. So next object weight is P1 by W1, but its capacity P1 by W1 that equals 10. Its weight is 10, but knapsack contains free space only 9. Okay, knapsack contains free space only 9. Now read the complete problem. They are asking maximal capacity is W. It is a maximum profit by using optimal algorithm and by using greedy method algorithm. Using value to weight ratio, find V app minus V greedy method. Okay, is it clear friends? Okay, so in this case actually we need to include one more point here, that is nothing but objects cannot be splitted in this problem friends. Okay, objects cannot be splitted, that is missing in the PPT. So we can say, we can also mention that note that objects cannot be splitted. So if now object cannot be splitted, in that case what you have to do, it is already occupied 2 units of space, remaining we have only 9 units space. According to algorithm, we need to take first object, but first object weight is equals to 10. First object weight is equal to 10. So I cannot take this one, right? Okay. So what about next one? P3 by W3. Third object weight is equals to, if you see P3 by W3, third object weight equal to how much? 4. Is it clear? It is 4. So can I place this object? Yes, I can place. So I can place that object and I will get profit is equals to 20. So with respect to third object, it is 20. Right friends? Okay. Then total space occupied is equal to 6. Remaining space is only 5. Remaining space is only 5. But here fourth object weight is equals to, fourth object weight, next one, sorry, not fourth object, second object weight that equals to P2 by W2. So that equal to 7. I cannot place this object friends, okay, because space is only 5 is available here. We cannot place object whose weight is 7. Therefore, by using greedy method, it is taking 44. By using greedy method, it is taking 44. If I apply dynamic programming, that is 0-1 knapsack problem, either you can place or you can ignore. In that case, maximum profit I can directly get by using first object. Right friends, the first object is generating maximum profit is 60 and it occupies space is equals to 10. So therefore, V optimal value is equals to 60, where V greedy method value is equals to 44. The difference between these two is equals to 16 friends, okay. So answer to this question is 16. So note that objects cannot be splitted in this problem. Generally, the fractional abstract problem, objects can be splitted, but in this problem, we are providing objects cannot be splitted, friends. Okay.
In this video, I'm going to discuss about pre-GATE exam. All TOC questions are going to be explained with the complete solution. We going to have first of all the 1 mark questions in detail. After that, I'm going to talk about what the 2 mark questions has been provided, and with the complete solutions you can see in this video. Let's look into the first question of the 1 mark. Which of the following languages are over the alphabet 01 is regular? L1 is equal to W such that W has even number of zeros and even number of ones. L2 W such that W ends with 01. L3 0 power n, 1 power n such that n is greater than 0. Option D is L4 W such that W has at least 1 0 and 1 1 in the language. So there are 4 options with us. We need to figure it out which of the following languages are regular. This is the multiple solution question. We have to find it out what are the right answers, what are the languages fall into the category of regular, and what are the languages are not come into the regular. You have to differentiate right now. And in this question you can see except option D, remaining all options are very known options for all of us. Here I just provided only a change in the option D. That is bit different question or different option has been given, but it's similar to the one of the previous questions which I given in the previous mock examinations. Let's come to the detailed explanation of it. Take the first one, the language L1 whatever you have with us, that is completely regular language. This is very popular language, even number of zeros and even number of ones machine. Already we are already discussed about all these solutions in detail in the classroom itself, and same question they can also put in a different way. Option A, you can also see it as set of all strings over 0 1 such that number of zeros divisible by 2 and number of ones are divisible by 2. Instead of asking this question as a even number of zeros and even number of ones, they can make it as a number of zeros are divisible by 2 and number of ones also divisible by 2. So that is the one solution also you can think about it. And this is the popular one. As you know, there are 4 states are required for it. Those 4 states diagram, if you draw that 4 state diagram, final states, if you keep changing, you will get about the different solutions for different kinds of languages that also expand in the classroom. So that's why I'm not going to the detailed one about it, because A is regular. After that, coming to this one. So when it comes to this one here, option B is absolutely regular language. This is also very popular language for all of us, because we have designed the machines, we have the regular expressions. For any language, if you have a regular expression, definitely that is a regular language. As you've seen, this is the regular expression for this language. As there is a regular expression for this language, therefore this is also regular, this is also regular. And this is context free language, because it is a equal number of zeros followed by equal number of ones. Then coming to the option D, this is something new, not compared with the previous options or previous questions. What I mentioned, at least 1 0 1 1 should be there in the language. In everywhere you should have here at least 1 0 and 1 1. You remember we are already discussed one question about the similar model, set of all strings containing the at least 2 zeros, at least 2 zeros. This is similar to that. This is similar to that. Here is asking not only at least 2 zeros, he is asking for at least 1 0 should be there and 1 1 should be there in the language. Therefore, I can say that you can easily write a regular expressions to this kind of languages here. Just see what is the regular expression for this. Everywhere I should have a 1 0 and 1 1. That means before of it you can also have a 0 plus 1 whole star. After that also you can have anything on the zeros and ones here. Then followed by this one also I can have anything on this here. To say whether this expression is correct or not, your only objective is here should verify the language members. My first string of this language is a 0 1 here, right? Next string you can also say that 1 0 can be there here. Can I have these two from this? If you take this, this will give me the first string is a 0 1, right? But if you have here want to have here 1 0, can I have? No. So that's what you can also rewrite instead of being like this, it can be happening first 0, after that it can have the 1 next. So if you keep add here something new to this, 0 plus 1 whole star 1 or 0 plus 1 whole star into 0, right, and 0 plus 1 whole star here. So if you take all these language members now, definitely you can generate every string whatever is there in the option D. So that's why this is benchmark question of the containing at least 2 zeros is the basic target, basic reference model for this option D. So therefore the right answers are here A, B and D. So I write answers are here A, B and then D here. And this is not a regular, this is a context free. This is what we are all know that. Therefore right answer of this one is ABD. Next I am coming to the next question here on the concept of decidability and decidability. You know, decidability, undecidability related concepts are here completely theory based questions. I also given you about very important note about it, and very important point I shared with you all. The question whatever may be on the topic of finite automata on regular languages. Any question which is related to the finite automata on regular languages by default decidable concept. So that's why you please do remember the question whatever is asking here, that is a by default decidable. See what is asking here, recursion and DFA machine. He mentioned that M is a DFA and M recognizes the input W. The language rec DFA is by default decidable. So whatever may be the language given to you on the topic of the finite automata on regular languages, you need to consider it is a by default decidable one here. See, undecidable one represents here if there is a no algorithm to answer that kind of question, then it is undecidable. If there is a decidability concept, you please understand the machines are always halting, the machines are always terminating. So any question whatever you are taken where you feel suppose there is a machine is always being halting here, that always consider as a decidable concept. That's the main point you have to understand. If there is an algorithm existing to solve the problems and all, and if you have definite algorithms which is working for the infinite cases, that is also decidable concept. when there is a Turing machine for us to recognizing about only L values, but we are not aware about the L dash values, the machine may be halt, may not be halting. All such a cases you should consider as what? Semi-decidable or Turing recognizable languages. So that's why you please remember, if there is no algorithm at all, or if there is no Turing machine at all, you should consider it as an undecidability concept. If there is a Turing machine to recognizing the L values and we don't have here clarity about what is happening for the L dash values, you should treat they are going to be the Turing recognizable languages or semi-decidable languages. So you please remember these 2 points, and then definitely you can work on more number of questions on this topic based upon the questions I provided in our classroom. Now let's look into the 2 marks questions. I gave you 2 questions on the 2 marks. One is about context-free languages and decidability concepts. Second thing is I provided about language recognition, whether those languages are here context-free or context-sensitive or regular language, right? So these models are very important. So one question is all about how the language can be here noticed as regular language or context-free language. That's the most important part of this entire discussion. You also just provide more emphasis on these kind of category questions. Now just look into the first question here. What is there with us? Assume that statements S1 and S2 and S3 given as. Statement number 1, given a context-free grammar G, there exists an algorithm for determining whether L of G is infinite. Statement 2, there is an algorithm to determine whether 2 context-free grammars generate the same language. Statement number 3, there exists an algorithm to determine whether type 0 grammars generate the same language. Which of the following is true? S1 is correct, S2 as well as S3 are not correct. Option B, only S1 and S2 are correct. Option C is S1 as well as S2 are correct and S3 is not correct. Option D is S1 is not correct and S2 is correct. So here you have to find it out what statements are correct statements, what are the wrong statements in this. See the first statement. Given a context-free grammar G, there exists an algorithm to determine whether L of G is infinite. Already in the list of decidability concepts under the context-free grammars, I provided this. We know if given grammar is context-free, it is always possible to determine whether the language of the context-free grammar is finite, infinite or empty. This all 3 statements considered as decidable statements. So therefore what you can say about it? Definitely you can consider all these 3 statements are what? Decidable statements. For that we have an algorithm called CYK algorithm, in which we try to construct always a graph using the grammar. If grammar generate the cycles, definitely that going to be have about infinite strings. If it is having no cycles in the graph, then it's going to be considered as always like a finite language. So that is the concept of CYK algorithm was provided you in the previous videos, that you can just check it up. So now statement number 1 is exactly the same. We have a context-free grammar with us. We have the context-free grammar with us, you know this. So let's say this is the CFG, right? So this is the G. Okay. Now what I am trying to tell you here, context-free grammar G is there with you. Now we are trying to find here whether L of G is equal to finite. So we are asking, is L of G finite? Is L of G equivalent of infinite? And is L of G equivalent of empty? So this is the one you have to find it out here. So these all statements I mentioned that these are the decidable statements. For all of them you have a CYK algorithm. So that's why the statement number 1 is absolutely correct statement. Then coming to the statement number 2, there is an algorithm to determine whether two context-free grammars generate the same language. There is no such algorithm to check out whether the languages of two context-free grammars are identical. This is the one of the important statement I gave you. There is no algorithm to that, or else this statement is undecidable statement. We cannot provide, if there are two grammars like a G1 and G2, these two are the CFGs, right? These two are the CFGs. We cannot check this one, L of G1 is equal to L of G2. This one you cannot check it. And not only this, even it is the subset of it. That is also not possible to be verified. So there is no algorithm for it. So therefore this is a false statement for all of us. And there is just an algorithm to determine whether type 0 grammars generate the same language. For that also there is no specific algorithm to provide you whether it is going to be true statements or false statement. But there is no algorithm, so that's the reason you will also consider this statement is also false statement for us. So this is also false statement. Only right answer is S1 is correct statement and S2 as well as S3 are the not correct statements. So that's absolutely right answer of this question here. After that, finally, we have one more question on the language recognition. Whether the given languages are here, given language is here context free or regular, undecidable, that's what they are asking us. Look at this one. We have this language and there are two conditions for this one here, whether I is equal to j you should say, or j is equal to k you should say. So this one if you write differently, a power I, b power j, c power k. So this is what the language. Now you have to check out here whether it is going to be I is equal to j or j is equal to k. So these two you have to verify here. So whenever you have here such a languages, this definitely can be designed with what? Non-deterministic push down automata can be used to design to this one here. Because you can design your machine with respect to this condition, one, another condition is this. So with these two conditions you can do that job here. Alright. So now what you can say here, whether I is equal to j you can prove or j is equal to k also you can prove. That's the reason you can consider this language can be the context free language, but not regular. You can't have a finite automata to this. So this is not the correct statement here. And L is a context free but not regular. This is absolutely true statement. And he mentioned that it's not a context free but decidable. No, this is also this is a context free actually. This is a false statement. And finally L is undecidable. No, so this is also false statement. It is a decidable statement because you have the PDA. You have the PDA to that. So friends, what I am trying to give you in this pre-gate exam, the concept of the decidability and undecidability I brought mostly into the picture here because you are all seen those kind of questions as a standard statements, but you are not seen with respect to the languages. I just taken the language and also correlated with the concept of decidability and undecidability. As there is a PDA, definitely whenever you apply a string to the PDA, always the machine is going to be terminated. Whenever it is a terminating on every string, you will consider that's a decidable statement, or else you say it is a recursive language. So, as there is a concept of PDA to recognize that, definitely all such languages are here recursive languages, or else context-free languages. You will remember all the time about this statement. If any machine, wherever machine is halting, you take them as a recursive language or decidable statements. So, recursiveness and decidability is interchangeable terms, right? They are interchangeable terms. That is the key point you have to remember from this pre-GATE examination. I wish you good luck for coming up examinations.
Hello students, here in the question given, consider the syntax directed translation scheme given below. The translation scheme given is A derives P, Q, R. And what is the semantic rule? AX means the attribute of A getting its value from Px and also getting its value from Qx and also getting its value from Rx. It is meaning that X is derived from its children. Because the value of X is derived from its children, then X is called synthesized attributes. Now, what is a synthesized attribute? An attribute is said to be synthesized if its value is defined in terms of its children's, then that attribute is called synthesized attribute. Now, question is, which of the following best define the type of X? What type of attribute X is? Synthesized attribute. If it is to be inherited, it should derive its value from parent and our siblings. But here, it is defined in terms of children's, then we can call it as a synthesized attribute. So, correct answer for the question is option A. Look at, consider the parsing table of SLR of 1 and LALR of 1 for a context-free grammar. Which of the following should be equal in both the tables? Just recollect what is difference between SLR of 1 and LALR of 1. In SLR of 1, LALR of 1, we know that number of states are same. Number of states are same number of states. Because same number of states, number of shift operations will be same, because transitions with respect to terminals are same. Because state diagram for SLR of 1 and LALR of 1 is same, because number of states are same. Okay, so that the state transition with respect to terminals are same, means shift entries are same. State transition with respect to non-terminals also same, means state transition with respect to non-terminals are called go-to part. Go-to part also same, because we know that SLR of 1 and LALR of 1 having same number of states. Number of states are same. What it is differs in SLR of 1, reduces we fill in all follow terminals. Reduces in all follow terminals. Here reduces in only look ahead terminals. Every look ahead terminals means every follow terminal need not be a look ahead terminals. Look ahead terminals are different, follow terminals are different. So because the reductions happens in SLR of 1 in follow terminals, in LALR of 1 in look ahead terminals, then reduce entries are different. When reduce entries are different, some entries that are filled in SLR of 1 may not be filled in LALR of 1. So if it is filled, that is reduce. If it is not filled in LALR of 1, that reduction, that entry is called error entry. Or here it may be conflicting entry, here it may be not conflicting entry. Means, so the number of error entries definitely be different. Number of error entries definitely different, because reductions in SLR of 1 is in all follow terminals, here in all look ahead terminals. So what is common? The common is number of states are common, so that state transition with respect to terminals causing shift entries are same, state transition with respect to non-terminals, so go to part is same. So correct answer is both A and D. Now, the number of states in DFA for the collection of items in LR of 0 of the following grammar? Number of states. In DFA for the collection of items in LR of 0 of the following grammar. So how many states? Numerical answer type question for this grammar. How do you find the states starting with S dash tends to dot S? So dot S is there, we have to add S production, S tends to dot AS, dot BS, and S tends to dot D. This is one state, 0 state. If you move dot one position, okay, now this is the first state. Now if you move dot one position to the right with respect to S, we are going to get S dash tends to S dot. This is a second state. If you move dot with respect to A, what we are going to get? S tends to A dot S, because dot S is there, again we write S productions, dot AS, dot BS, and dot D. This is a third state. With respect to B, what we are going to get? S tends to B dot S, because dot S is there, S productions, dot AS, dot BS, and S tends to dot D. This is a fourth state. With respect to D, what is possible? S tends to D dot. This is a fifth state. Now from one state, we got 4 possibilities. Now from third state, with respect to S, S tends to AS dot. This is a sixth state. With respect to A, you are going to get the same thing. Means S tends to A dot S. Again, you are getting the same state. With respect to B, you are going to get B dot S, means fourth state. With respect to D, we are going to get the same fifth state. Now with respect to S, S tends to BS dot possible. This is a seventh state. With respect to A, you are going to get this state. With respect to B, you are going to get this state, because A dot S means this one. B dot S means same fourth state. With D, that is, you are going to get fifth state. Any more possibilities? No. So how many states are there? 1 to 7. The number of states are 7 states. 7 is the correct answer for the question. Here it is given, consider the following syntax directed definition. S tends to GA is a semantic rule, grammar production. The remaining are semantic rule. G tends to plus is a grammar and semantic rule. G tends to minus, grammar and semantic rule. A tends to A1N, grammar and semantic rule. A tends to N, grammar and semantic rule. Now what is given? The syntax directed definition uses 2 attributes. One is called sign, another is value, and N is any integer value. Now the question is the output produced by the given syntax directed definition for the input plus 2, 6, 3, 4 is. So I'll write the input plus 2, what is given? 2, 6, 3, 4. 2, 6, 3, 4. It is the input. Now what is the output for this input? And it is also mentioned this operator double line is called concatenation operator. Now what we have to do? We have to construct a tree for this input and find the output. To construct a tree for this input, we have to start with S tends to G A. S tends to G A. So S value equaled A value, that semantic rule is there. Now what we have to get with G? We have to get plus. So we can write G tends to plus. Next with A, we have to get 2, 6, 3, 4. To get 2, 6, 3, 4, A has 2 productions. A tends to A1N and A tends to N. So what we can do? A tends to A1, N, that is a 4. Last one and comma derived. Again A tends to, this A1 is an instance of A. That A tends to A1, N, 3, N is derived. Again A tends to A1, 6, 6 and comma there. Then A1 tends to 2. That is A tends to N. Now plus 2, 6, 3, 4 is there. Right now. Now what we have to do is, now evaluate the semantic rules. G tends to plus had a semantic rule G sign equal to 1. Now A1 tends to 2. A1 tends to 2. That is A tends to N had a semantic rule A1 value equal to n, that is true. Now this is like A tends to A1n, A tends to A1n. A tends to A1n had a semantic rule A1 sign you can get from the A sign, means this sign I'll use some different color for value and sign. Okay, for value I'll use one color, for sign I'll use one color to avoid a confusion. So A1 value equal to 2. Now for each A we also have a sign. Now this A1 sign you can get from the A sign. Here also A1 sign you can get from the A sign. Here also you can get A1 sign you can get from the A sign. But here A sign S tends to GA had a semantic rule A sign equal to G sign. A sign you can get from the G sign. This is 1. So that here also 1, here also 1, here also 1. Right? Next, A tends to A1n had a semantic rule A1 sign is A sign, that is over. If A sign equal to 0 but sign is not 0, if A sign is 0 then A value is min of A1 value comma n, else A value equal to max of A1 value comma n, means it is required to find the maximum value. So what is the value? Value equal to max of A1 value 2 comma n. Max of 2 comma 6 is 6. Max of 2 comma 6 is 6. Same thing, A1 value. A1 value we can get max of, because sign is 1, we have to find the maximum. Maximum of A1 value 6 comma 3. Max of 6 comma 3, 6. It's upper. A value equal to max of, because sign is 1, then what is the value? Max of A1 value comma n. 6 comma 4, 6. Then finally, S value. S value equal to A value. What is the A value? S value equal to A value. S value equal to A value. What is the S value? Is 6. S value equal to A value. This is over. And it also have one print statement. Now you look at what that print statement is printing. What that print statement is printing. It is printing G sign concatenated with A sign. What is a G sign? 1. So here we have a print statement. Okay, I am writing a print statement that is going to be printed in the output. That is going to be printed in the output. What it is printing? G sign concatenated with A value. G sign is 1 concatenated with A value 6. So what it is going to be printed? 16 is going to be printed. Now what is the question? The output produced by the given syntax directed definition for the input. What it is printing in the output? Sign 1 and the value 6. So answer for this question is 16. 1, 6. 16 is the answer for the question. Thank you.
So now we are going to discuss about operating system questions in connection with this pre-GATE examination. This is what the given question. Look at this statement. Think about a process P1 running on a single core CPU system with an operating system like Linux. When a disk interrupt happens while P1 is running, P1 switches to kernel mode to handle the interrupt. All the disk blocks that unblock a process P2 within brackets which had previously blocked on the disk read are sent by the interrupt. The interrupt service procedure has finished running completely and the OS is preparing to switch back to P1 user mode. The state of the process P2 is dash. Option A ready state, option B running state, option C blocked state and option D exit state. So if you check this question carefully, the question is speaking about the state of the process P2. It is speaking about the state of the process P2. So where this process P2 is, if you consider here, it is clearly mentioning that all the disk blocks that unblock a process P2 which had previously blocked on the disk read. It is been blocked previously. So you know we are having a process state diagram. This is what your ready state, right? This is what your running state Okay, this is what your running state and this is what your waiting state, or else you can say blocked state. So now if you see, when the disk interrupt happens while P1 is running, so P1 is running here. Now disk interrupt is happened. Then P1 switches to the kernel mode to handle the interrupt. Okay, so then all the disk blocks that unblock a process P2 which had previously blocked on the disk read, it means disk operation, by the time where this P2 is part of blocked state, it means here it is. So now P1 is switching to kernel mode to handle that interrupt. Why this interrupt is occurred? Because the disk interrupt is been happened. So then what is going on? The interrupt service procedure have finished the running completely, right? So means the interrupt, whatever the interrupt is been occurred, that interrupt is been serviced here, and then the OS is preparing to switch back the process P1 to user mode. The state of the process P2 is, it means now P2 is here. Now interrupt is been serviced. Once the interrupt is been serviced, then what will happen? This P2, the interrupt is being serviced, then previously it is blocked, right? So previously it is blocked, all the disk blocks, the interrupt is happening because of the disk blocks. Now all these disk blocks are unblocking the process P2, unblocking the process P2 in the sense this process P2 is moving from waiting state to ready state. So this is what the concept behind this question. So hence the answer for this question is option A. Okay, right. So let's move to the next question. So look at this question, which of the following statements is or not true? The question is speaking about not true. Mind this, it is speaking about not true. Okay, right. Look at the option A. A process in user mode can execute certain privileged hardware instructions. Option B, two running processes share the complete process image in physical memory. Option C, a process undergoes a context switch every time it enters kernel mode from user mode. Option D, PID information in the PCB of a process is changed when the process invokes the execute system call. So if you consider option A here, a process in user mode can execute certain privileged hardware instructions. See, a process in user mode can execute certain privileged hardware instructions. Actually, privileged instructions are executed in the kernel mode, but not in user mode, right? User mode is non-privileged mode, correct, no? Kernel mode is your privileged mode. So privileged instructions can be executed in the privileged mode, means kernel mode, but not in the user mode. So that's why option A is false. Then option B, two running processes share the complete process image in physical memory. So two running processes share the complete process image in physical memory. This is also false because the process image is unique per process. They cannot share the same image. So that's what the meaning. So process image is different from one process to another process, or else process image is unique. That's why the statement is false. Then option C, if you check, a process undergoes a context switch every time it enters kernel mode from user mode. So this is not necessary. Whenever there is a context switch, it is not necessary to move every time to enter into kernel mode from user mode. So this is also false. It is not necessary actually, right? Then option D, if you check, PID information in the PCB of a process is changed when the process invokes the execute system call. So this is also false. Reason, when a process is whenever a process is invoking the execute system call, then obviously the PID information will not get changed. It will not get changed because it is in execution now, right? It is invoking the execution system call, so that it is not changed. PID will not be changed. So that's why this statement is false. So as the question is speaking about not true, means it is speaking about overall false statement. So as all the options are false, we can say the key for this question is A, B, C, D, all options. Okay, right. Let's move to the next question. So what is this question is speaking about? Consider the following processes that arrive in a system at specified times along with the duration of their CPU bursts. Process P1 arrives at time t0. So let's say this is what your process PID and arrival time and execution time. So process P1 is arrived at time 0 and has a CPU burst time of 10 units. Next, process P2 arrived at 2 and has a CPU burst time of 2 units. Process P3 is arrived at 3 and has a CPU burst time of 3 units. Assume that the process executes only once for the duration of their CPU burst and terminates immediately. So, which of the following is are true? Option A, FCFS and SJF algorithms result same completion time of P1, P2 and P3. Option B, P1's completion time is same in both round robin and SRTF. Option C, in SRTF algorithm, P2 is completed later P3. In option D, in round robin with the time slice is equals to 5, right, with the time slice is equals to 5, P3 completed later P2. P3 is completed later P2, right. So, this is what the question statement. So, the question is speaking about FCFS algorithm, SJF algorithm, SRTF algorithm and round robin algorithm. So, first if we consider with FCFS. So, what is the Gantt chart for this FCFS if you check? At 0, P1 is arrived with 10 execution time. So, as you know that FCFS is non-preemptive, it gets executed completely. So, by 10, I am having P2 process and I am having P3 process with their execution times of 2 and 3. Then who will go? As P2 is arrived first, P2 will go. P2 is going to get executed up to 12. By 12, you are having only P3 process with 3 execution time. So, since it is alone process, we can hand over it, it gets executed by 15. Right, 15. So, completion time if I write with respect to FCFS, P1 is finished at 10, P2 is finished at 12, P3 is finished at 15. Now, if you consider what is option A, FCFS and SJF results same completion time of P1, P2 and P3. Okay, let's consider SJF now. If you consider SJF Gantt chart, if you consider SJF Gantt chart, at 0, which process is arrived? Only P1 is arrived. With how much execution time? 10 execution time. So, since P1, as SJF is also by default non-preemptive, it can be executed up to 10. So, by 10 I can have P2 process, I can have P3 process also. P2 is there with 2, P3 is there with 3. Then among these two, which is the shorter one? P2 only. So, that is why P2 will go and it gets executed up to 12. Then P3 is the alone process by 12. So, P3 will go on to the CPU, gets executed up to 15. So, now if you check the completion time of, so SJF, this is what completion time with respect to SJF. So, white color I am representing with SJF, yellow color I am representing here with FCFS, the completion time. Okay, right. So, now if you look into the completion time of P1 according to this Gantt chart, it is 10. P2 12, P3 15. So, if you verify P1 completion time, P2 completion time and P3 completion time with respect to both FCFS and SJF, it is true. I mean it is equal, right? That is what option A is saying. FCFS and SJF algorithm results the same completion times of P1, P2, P3, which is absolutely true statement. Next, if you consider SRTF and round robin. So, P1's completion time is same in both round robin and SRTF, and the round robin is using time slice of 5 units. Okay, let's check with SRTF. Let me use some different color. So, SRTF, if you take the Gantt chart, if I draw, at 0 I have P1 process with 10 execution time. And this P1 only alone process, so that I can continue this process execution. I mean I can hand over this P1 to the CPU and it is allowed to get executed up to the next arrival. What is the next arrival? Till 2. By 2, P1 is running with the 8 remaining burst time. By 2, who is coming? P2 is coming with how much execution time? 2 units. So, now if you check, the newly added process execution time is less than the currently running process, so that preemption takes place, means P2 will go on to the CPU. So, this P2 will be continued up to the next arrival. What is the next arrival? 3. By 3, P1 is already there with 8 execution time, P2 is there, P2 is running with the 1 execution time, right? P2 is running with 1 execution time, and P3 is just arrived with 3 execution time. So comparatively the newly added process, the currently running process execution time is still shorter, so that no preemption. So means P2 can be continued here up to 4. Then by 4, you are having P1 process with 8 remaining burst time, and you are having P3 process with 3 burst time. Among these two, which is shorter? P3. So P3 will go on to the CPU, gets executed up to 7. Then I have only P1 process in my running in my ready queue. So since it is alone process, we can hand over it. It gets executed up to 15. This is what the Gantt chart for SRTF. I mean, this is what the Gantt chart for this system if I apply SRTF. So what the question is speaking about, P1's completion time. Okay, so here P1's completion time we have to check. So P1's completion time, if we consider in the context of SRTF, P1's completion time if I consider, what is that? 15, right? By 15 it is getting finished. Right, now if I consider round robin, okay? So round robin. So I just considering round robin, ready queue and Gantt chart implementation here itself. At 0 I have only P1 process. So that at 0 P1 starts its execution and the time slice is 5. So that up to 5 it gets executed. By 5 who is coming? Both P2 and P3 are coming. So P2 is there and P3 is also there. And with this execution, is the P1 is finished? No. Again this P1 can be added back to ready queue. Then what is the first process I am having? P2. So now P2 will start its execution. But what is the execution time of P2? Only 2 units. So up to 2 means up to 7 only it gets executed. With this P2 is finished, no need of adding this P2 back to ready queue. Then what is the next process I am having? P3. So P3 will start its execution. P3 total execution time is what? 3 units, right? So is it going to get executed up to 5? No, it is going to get executed up to 10 only. Okay. So with this execution, P3 is also finished, no need of adding this P3 back to ready queue. Then what is the next process I am having? Only P1 process. Up to what it is going to get executed? Up to 15, right? Up to 15. So total execution time of P1 is 10. Already it is executed 5 minutes here and now 5 minutes here. So with this execution, P1 is finished, no need of adding this P1 back to ready queue. Then with respect to round robin, right? Round robin with the time quantum is equals to 5. What is the completion time of P1? 15, right? Completion time of P1 is 15. So here I can write the completion time of round robin. So completion time of, this is what round robin, okay? Green color I am using for round robin. For P1 the completion time is 15. So verify, P1 completion time in the SRTF is 15 and P1 completion time in the round robin is also 15. So what is option B is saying? P1's completion time is same in both round robin and SRTF, which is also true. Now option C, if you check, in SRTF P2 is completed later P3. It means P2 is finished after P3. Verify, P2 is finished. What is the finishing time of P2? 4, P3 7. So P2 is finished after P3? No, this is false. Right, P2 is finishing first and then P3 is getting finished. Next, coming to, in round robin, P3 is completed later P3. P3 is completed later P2. It means P3 is completed after P2, right? So P3 is completed after P2, which is true, right? So this is true. So overall, if you check, option A is true, option B is true, and option D is true. So the answer for this question is A, B, and D. So this is the key for this question. Okay. So I hope you are clear with this. So let's move to the next question. So coming to this question, this is what the given code. Consider a parent process that has a forked a child in the code snippet below. Int count is equals to 0, RET is equals to fork. Okay, whatever the value that is returning by fork, that value we are saving into RET, right? Okay, so initially I am having parent process, let's say P0. When this fork is being executed, this P0 is creating P1. Then as it is a fork, it is returning value 0 to the child process, it is returning positive value to the parent process, means the child process ID to the parent process. Now this if clause condition, if RET is equals to 0, this is equals to 0 to whom? Only to the child, so that only P1 can enter into this if clause. Only P1 can enter into this if clause, and this P0, as it is having positive value, this if clause condition is false, so that P0 will come here. So P0 is going to store value 1 into the count, and P1 is going to store value 0. So count in count in child is equals to percentage d, that is count, right? So what does it mean? What is the value that we are having in the count? Initially that value is 0, that 0 only the child is going to happen here. So it means the count value here, it is coming to 0 only, because the parent is the child is executing this printf statement, but the parent is storing value 1 into the count. So parent is storing value 1 into the count, but the child is storing value 0 into the count. Okay, so according to this analysis, if you check these statements, consider the following statements. Statement 1, the parent executes the statement count is equals to 1 before the child executes for the first time. Yes, it is true. It is storing value 1 only, right? Because you know that both parent and child can execute in parallel. So it is if it is coming to if clause statement, and it is storing count is equals to 1. Next, the value of count printed by the code is above is 0. Yes, it is also true, because printf statement is executed by whom? Child process, and child process is storing count in child, percentage d, again count. It means what is the value of count? 0 only. So the child process is going to print 0 only. Okay, so that's why this statement is true. So the question is speaking about which of the above statements are true. So both option A and option B, means you can say both statements are true here. So both S1 and S2 is the true statement. So option C is the answer for this question. Next, coming to this question statement, consider a simple system running a single processor, right? Single process. The size of the physical memory, the size of the physical frames and the logical pages is 16 bytes. So what does it mean? The page size and the frame size is given as 16 bytes. The RAM can hold only 3 physical frames. Okay, the virtual addresses of the process are 6 bits in size. The program generated the following 20 virtual address references as it runs on the CPU, 0, 1, 20. So some addressing sequence is being generated. Okay, so then assume that the physical frames in the RAM is initially empty and do not map to any logical page. The number of page hits generated by the access if FIFO page replacement algorithm is used. So here this is what the references, right? These are the addressing sequence, but not page reference string. So you have to convert this addressing sequence into page reference string. So as the page size is 16 bytes, I can have page 0 which is having 0 to 15 bytes, page 1 storing 16 to 31, page 2 holding 32 to 47, page 3 holding 48 to 63, right? 63, yeah. So that's it. So nothing is more than 63, right? All addressing sequences are within the 63. Yeah. So now if you see, first page reference string from here, page reference string I am writing now. 0, this is the 0 byte which is related to page 0, 1 byte related to page 0, 20 related to page 1, 2 related to page 0, again 20 related to page 1, 21 related to page 1, 32 related to page 2, 31 related to page 1, 0 related to page 0, 60 related to page 3, 0 related to page 0, again 0 related to page 0, 16 related to page 1, 1 related to page 1, 17 related to page 1, 18 related to page 1, 32 related to page 2, 31 related to page 1, 0 related to page 0, right, and 61 related to page 3. So now this is what the sequence page reference string. So for this page reference string, how many page references you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So how many addresses you are having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So total you are having 20 references, and apply FCFS with 3 page frames. Okay. So initially 0 is not there in the memory, so that it is a fault, and bringing it from secondary memory to main memory. Now CPU is interested to access page 0, but page 0 is already there, it is a page hit. Now CPU is interested to access page 1, but page 1 is not there in the main memory, fault, and bringing it from secondary memory to main memory. Now CPU is interested to access page 0, yes, page 0 is already there in the main memory, which is a hit. Again 1, it is already there in the main memory, hit. Again 1, which is already a part of the main memory, which is again hit. But 2 is not part of main memory, which is fault, right? So then 0, 1, 2. Then 1, which is a hit, 0, 1 and 2. 0 again hit, because 0 is there in the main memory. Now 3. So as it is FIFO, which page I have to choose in the context of this 3 page fault, right? So we need to bring which page we need to bring. So this is so up to now this is page fault, this is hit, and here this should be hit, right? This is also hit. This is also hit. Okay. Now 3 I should bring, so that 0 is going to get replaced. 3, 1 and 2. This is a fault. Now 0, 3, 0 and 2. This is also fault. But now this is a hit, right? This is a hit, 3, 0, 2. Now 1, it is a fault, 3, 0 and 1. Now for these 3 ones, you are having 3 hits, because 1 is there. So by this one, what is your main memory? 3, 0 and 1. So now 2, which is fault, but which one we should bring among these 3, 0, 1? 3 is entered here, 0 is entered and 1 is entered. So 3 is going to get replaced by 2 here. So 2, 0 and 1. Then with respect to 1, it is a hit, with respect to 0, it is a hit, but with respect to 3, it is going to be fault. So now overall, how many page hits we are having? So verify, we are having one, this is a, let's say if you calculate number of page hits or else number of page faults, anything you can consider. Let's say if you calculate page hits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 number of page hits we are having. And how many number of page faults? If 12 number of page hits, obviously we are having 8 number of page faults. So, but the question is speaking about page hits. So as the question is speaking about page hits, the answer for this question is 12. Because 12 number of page hits we are having and 8 number of page faults we are having. So 12 is the answer for this question. Okay, right. So coming to this question, consider a system with 8-bit virtual and physical addresses and 16-byte pages. A process in the page in this system has 4 logical pages which are mapped to 3 physical pages in the following manner. Okay, so the page table is being given here. Page table is being given. Logical page 0, this is the page number, this is the frame number. Page 0 is part of frame 6. Page 1 is part of page frame 3. Page 2 is part of frame number 11. page 5 is not mapped to any physical page yet. So page 5 is not yet allocated to any frame. All the other pages in the virtual address space of the process are marked invalid in the page table. Okay. So the MMU is given a pointer to this page table for address translation. Further, the MMU has a small TLB cache that stores 2 entries. So TLB, you are having TLB also. So this is what your TLB. It is having 2 entries. One entry is what? Logical pages 0 and 2. For logical pages 0 and 2. So 0 is part of 6 and 2 is part of 11. So this is what TLB part and this is what your page table part. Okay. Then the physical address, if the logical or else virtual address is 20. Okay. If the logical address and virtual address is 20, then what is the physical address here? So the logical address is being given 20. And page size, it is a 8-bit virtual address. The question is clearly mentioned 8-bit virtual address. So this is a 20. So if I write this 20 into 8-bit mode, for example, 0, 0, this is 2 power 0, this is 2 power 1, this is 2 power 2, this is 2 power 3, this is 2 power 4, right? This is 2 power 5, this is 2 power 6, this is 2 power 7. So 20 I need. So 16, and which means this should be set to 1, and 4, this should be set to 1. So 000 1 0 1 00 is my logical address, 8-bit logical address. And pages are 16 bytes. My page size is 16 bytes. So 16 bytes. 16 bytes in the sense the page size is 16 bytes, in the sense it is 2 power 4 bytes. What does it mean? 4 bits are comes under offset. So these are the 4 bits. Okay. So these are the 4 bits that are comes under offset. So this is 2 power 3, right? So these 4 bits are comes under offset, and these are the bits comes under page number. So now page number is 1, and this page number 1 is mapped to page number 3 in frame number, right? Page number 3. So then address in physical address, offset is same. What is that offset? 0100. Okay. So now this is mapped to frame number 3. What is the frame number 3 in 4-bit? This is what your frame number 3. Okay. So frame number 3. So this is frame number 3 and this is offset. So overall, if I convert this into decimal, now the question is asking about the physical address in decimal. So 2 power 7, 2 power 6, this is 2 power 5, which is 32, plus this is 2 power 4, 16, plus this is 4. So 20 and 52 is your physical address. So 52 is the answer for this question. Okay, 52 is the answer for this question. That's it.
Hello students, here in the question, it is given a relation R with attributes A, B, C, D, E and the set of functional dependencies A to B, B, C to D, E to C, D to A given, and asked to choose the correct option. The options are: the relation R has exactly 2 candidate keys, R has exactly 3 candidate keys, pairwise candidate keys of R do not share any attribute, and pairwise candidate keys of R sharing some attributes. Okay, it is all about candidate keys. First, you have to find the key of the relation. To find the key of the relation, always I suggest you start with the independents. So, because we have to start with the independents, first remove dependents. B dependent, D dependent, C dependent, and A dependent. E is the independent. Now, what is the closure of E? E and C, not all attributes. So, E is not a key. But you have to add some attributes to form a key. What you can add to E? AE, A you can add, B you can add. Adding C is of no use because E closure already having a C. Even if you add C, you will get EC only. So D, right? D. So AE, BE, DE, 3 possibilities. Now take the closure of AE, AE with AB possible, with EC possible, with BCD possible, all attributes. What is a BE closure? BE with B, nothing is there, with E, C possible, with BC, D possible, with D, A possible, correct. What is DE closure? DE closure is DE, with E we have C possible, right? With E we have C possible, with D, A possible, right? So look at DE closure, DE, with E, C possible, with D, A possible, with A, B possible, right? With A, B possible, all attributes are there. So means how many candidate keys are there? 3 candidate keys. What are the 3 candidate keys? AE, BE and also DE are the candidate keys. Now first statement you look at, the relation R has exactly 2 candidate keys. Is it exactly 2? No, it is exactly 3 candidate keys. So option B is correct. And pairwise, the candidate keys of R do not share any attributes, but all these candidate keys are sharing one attribute in common, that is E, because E is an independent attribute. But what it says, do not share. So it is wrong. So what it is sharing? Pairwise, the candidate keys of R sharing some attribute. What attribute is it is sharing? E attribute it is sharing. So what is the answer for the question? Both A and D. So that correct answer for the question is B and D. Next question. Hello, here what it is given? A sorted data file on a disk with block size 2048 bytes has the following details. The number of records are 13,10,720. Record length 200 bytes. Primary key 13 bytes. Size of the block pointer 7 bytes. For this file, we need to build a multi-level index on the primary key. We have to build multi-level index on the primary key. Now question is, what is the blocking factor for the index file? Blocking factor for the index file. So given data is much, but asking only blocking factor for the index file. What is the blocking factor for the index file? Block size by size of index record. Index record size. Now tell me, in this given data, what is a block size? Block size, here you look at block size mentioned 2048 by index record size. What is an index record? Contains key and pointer. What is a key field? 13 and pointer field is 7. Means 2048 by 20. And when it comes to the blocking factor, we have to take the lower part. That is 2048 by 20, we are going to get 102. So the correct answer for the question is 102 is the correct answer for the question. Now, it is a third question. Consider the following schedule S: R1x, W1x, R2x, W2x, R1y, R2y. The question is, which of the following is a non-conflicting pair of operations in the schedules? Question is about non-conflicting pairs. We know what are the conflicting pairs: read-write, write-read, write-write on the same data by different transactions. Operations of same data, not conflicts. Sorry, operations on same transaction, not conflicts. And operations on same data but both are read, does not conflicts. Keep in mind, read-read, not a conflict. Read-write, write-read, write-write may be there, but both are of same transaction, does not conflict. Those are called non-conflicting pairs. Remaining all are conflicting pairs. Question is about which of the following is a non-conflicting pair of the operations in the schedules. Option A is a non-conflicting pair. Why? Because both are of same transaction. Read-write is there, but both are of same transaction. Operations of same transaction does not causes any conflict. Write-read these are the two different transactions. One is write, another is read. It is a conflicting pair. But question is about non-conflicting pairs. B is conflicting pair. And C is also conflicting pair because these are the operations of two different transactions on the same data. Conflicting pairs. And these two also conflicting pairs. Read 1x, write 2x. Read, write. These are also conflicting pairs. So what is the correct answer for the question? Option A is the correct answer. Because we know what is a non-conflicting pairs. Read, read on same data is not a conflict. And read, read on a different data, not a conflict. Read, read on different transaction on same data, also not a conflict, because read, read is not a conflict. And read, write, write, read, write, write on same data by different transaction is a conflict, but same transaction not a conflict. That point you keep in mind. So these are read, writes only, but transactions are same, not a conflicting pair. It is the answer for the question is option A. Now, coming to this question. Consider the table's sales information given below. Table sales information. Columns are region, salesman, sales. Region, salesman, sales. These are the data given of the sales information. That is the table name is sales information. And here there are two students. One student is called Allika and another student is Gautami. Have written queries to get the below desired output. Allika and Gautami written two queries to get this output. What output they are getting? West, East, East, West, Alan 76, 7,60,000, East, John 1,24,000. Okay, just I will be marking it. West, Alan 7,60,000, East, John 1,24,000 and East, Nicholas 1,45,000. These three records are required to be in the output. To get this output, Allika and Gautami have written queries to get this output. What queries Allika written? Check it out. Allika query is given and also Gautami query is given. Two queries are given. Okay, now options are given. Both Allika's and Gautami queries are correct. Neither Allika nor Gautami and only Allika's, only Gautami's queries are correct. Check for Allika's query first. Select star from sales information, that is a table name, where lower of region, like lower of region, like percentile T. What does it mean? Region should end with T. This is says region ends with T. And upper sales one, upper salesman, like percentile N, means salesman column should ends with N. Ends with N. Or upper of salesman like N percentile. So means either ends with N or starts with N. Starts with N. Now the point you'll observe, this is starts with N, this is ends with N, this is ends with T. Okay, region ends with T, salesman is ends with N or starts with N. Okay, now look at region, salesman. Now region ends with T, salesman name ends with N or starts with N. So it is matching. Now look at this is also region ends with T, but salesman not ends with N, not starts with N. Here this is only failed. In the East, region ends with T, salesman name ends with N. This record is also in the output. So these two are correct. And here region ends with T is incorrect. T incorrect. T correct. Ends with N incorrect, but starts with N correct. So that this is also correct. Means Allika's query is correct, giving the correct output. So Allika's query is correct. Now we will check what Gautami written. Select star from sales information where lower of region like percentile TH. So means it is ends with TH, lower letters, or upper of salesman, salesman name ends with N or starts with N. That is the meaning. %n and upper of salesman like n %. So means the salesman name ends with n and salesman name starts with n. It is not r. Previously it is r na. Now this condition says and condition. It means Gautami written and. It means salesman name ends with n and, because here you look at and, starts with n. Starts with n. But region is ending with th. Region is ending with th. Look at, now region is ending with th, it is there with north, but salesman name ends with and starts with n is incorrect. But here it is not ending with th. This record you are not going to get in the output of Gautami. This region is also not ending with th, not getting in the output. This region is ending with th, starts with n, ends with n, correct. Only this record is there in the output of Gautami. And this is ends with th and region is ends with th, but start and ending with n is not correct. This is not with th, this is not in the output. Means Gautami's query is giving the output only north, no LAN, north, no LAN, and 5,90,000. That is only the output. But what we require, these three records are required. So it is not giving the required output. So that what we can say, Allika's query is correct, Gautami's query is incorrect. Okay, it is not correct. We can say not correct. So what is the question? Whose query will generate the desired output? Only Allika's query is generating the required output. So answer is only Allika's. Remaining options are wrong. Okay. You look at this question. Consider the two tables T1 and T2 shown below. Two tables are given. What will be the number of tuples returned by the following operations? Number of tuples in the output of the following operations. Now what is the number of tuples? T1 is joining with T2. T1 is joining with T2. Now what is the output? T1x is greater than or equal to 10. T1x greater than or equal to 10 is true for these two records. And T2x less than or equal to 10. T2x less than or equal to 10, less than or equal to 10 is true for these three records. Now here the two records of T1 now joining with three records of T2, this join will first performs a cross product. This join will first perform the cross product, so that T1x 10 greater than T1x is greater than or equal to 10 correct, and T2x less than or equal to 10, this is correct, this is correct, this is correct. Means for the first one we have these matches. And here also greater than or equal to 10 and less than or equal to 8 correct for these three combinations. For this also, for this any matches greater than or equal to 10 is wrong, so no more matches. So means how many combinations are there in the output? 2 into 3. Those are 6 combinations are in the output. So the correct answer for the question is 6. 6 is the answer for the question. Thank you.
So now we are going to see computer networks questions in connection with the pre-GATE examination. Look at the first question statement. So a TCP connection sends data at a rate of 1 Gbps. Find the TCP sequence number wraparound time. So we need to find out the wraparound time here. Okay. So bandwidth is given 10 power 9 bits per second. I mean 1 Gbps, and it is clearly mentioned 10 power 9 notation. Okay. So bandwidth is given 1 Gbps means 10 power 9 bits per second. What does it mean? In 1 second, okay, in 1 second, we can able to send 10 power 9 bits. Now what I can do, I can convert this into bytes. So in 1 second, 10 power 9 by 8 number of bytes. So why I am converting these bits into bytes? Because my TCP is byte oriented protocol. And in 1 second, if I am having these number of bytes, what does it mean? I can have these number of sequence numbers. Because you know TCP is byte oriented protocol. What is the meaning of byte oriented protocol? Assigning the sequence number to every byte, right? So if you are having these number of bytes and those number of sequence numbers are there. So that's what the meaning of this line. So one sequence number can take in 1 second, I am able to generate 10 power 9 by 8 sequence numbers. But if I want to calculate for one sequence number generation how much time, then how can I calculate? This is going to be 8 by 10 power 9 seconds it can take, correct? 8 by 10 power 9 seconds. But how many, you know that as part of TCP packet header format, the sequence number field is 32-bit. So as it is 32-bit, then how many number of sequence numbers you can able to generate? 2 power 32. If one sequence number is able to get generate 8 by 10 power 9 seconds, then 2 power 32 sequence numbers can take how much time to get generated? That is 2 power 32 into 8 by 10 power 9 seconds. So if you evaluate this particular expression, you are going to get something like 34.35 seconds, right? 34.35 seconds, 34.35 seconds. Let me look into the calculation part. So it can take 34.35 seconds. So 2 power 32 sequence numbers can take 34.35 seconds of time period to get wraparound. So what does it mean? After one time of generation from 0 to 2 to the power of 32 minus 1 sequence numbers, again to generate the same set of sequence numbers. Again to generate the same set of sequence numbers, how much time is being taken? 34.35 seconds it is taking with this 1 Gbps bandwidth. So that's why the answer for this question is 34.35. Okay, right. So coming to the next question. A transport protocol runs at 100 Mbps and uses 30-bit sequence number. The approximate maximum safe MSL is, MSL means what? Maximum segment lifetime, and we need to express in terms of seconds. Okay, so bandwidth is being given. How much bandwidth? 100 Mbps. 100 Mbps of bandwidth it is given. So, and it is clearly mentioned 1 Mbps is what? 10 power 6 bits per second. Okay, then in 1 second we are able to generate 10 square into 10 power 6 bits. We are able to transmit 10 square into 10 power 6 bits. In 1 second, 10 square into 10 power 6 by 8 bytes. Okay, bytes. In 1 second, 10 square into 10 power 6 by 8 sequence numbers we can have. Okay, sequence numbers we can have. So the question is asking about maximum segment lifetime, MSL. MSL it is asking. So you know that the question is speaking about 30-bit sequence number field. With the 30-bit frame sequence number field, how many sequence numbers you can generate? 2 power 30. So with the 30-bit sequence number field, we can generate how many sequence numbers? 2 power 30 sequence numbers can be generated. 2 power 30 sequence numbers can be generated. So therefore, what is the maximum segment lifetime? Therefore, the maximum segment lifetime is equals to 2 power 30 into 8 by 10 square into 10 power 6. So if you evaluate this particular expression, okay, you are going to get, if you evaluate this particular expression, you are going to get around 85.89 seconds you are going to get. 85.89 seconds you are going to get. Okay, so that's why the answer can be given as 85.8 to 86.0. So this can be the correct value for this particular question. So the answer for this question is this one. Okay, right. So let's move to the next one. So look at this question statement. An IPv4 packet has a total length of 5140 bytes, including 20 bytes IPv4 header and 8 byte UDP header. The packet is forwarded through a router whose MTU is 700 bytes. Assume that all outgoing frames have 20 bytes of IP header. Fragmentation offset is measured in 8 byte units. The fragmentation offset for the first fragment is 0. What is the fragmentation offset for the fourth fragment? Okay. So the question is speaking here, UDP header is there. Let's say this is what your transport layer and this is what your internet layer or else network layer. At this transport layer you are having UDP. This is what your UDP. This UDP is having 8 bytes of header and some data is there. This is the data field of UDP. And this is what your IP. This is what IP header. IP header is 20 bytes. Right? IP header is 20 bytes. And overall this IP is having the total length of 5140. Then you know that this UDP is part of the data field of IP. So this is your IP packet. Okay. So what does it mean? If 20 bytes is your IPv4 header and already 8 bytes are here, right? 8 bytes are here. Then what is the data portion you are having? 5120. This is the data portion of your IP. Data portion of IP, datagram is equals to 5120 bytes. Now this datagram, okay, this much data portion you have to forward through a router which is having MTU of 700 bytes. 700 bytes MTU, what does it mean? 680 plus 20. So verify, is 680 divisible by 8 or not? 680 is divisible by 8 or not? So 680 divided by 8. Yeah, it is divisible by 8. So what does it mean? This 5120, every time it is going to get fragmented in terms of 680. So therefore, number of fragments is equals to, how can I calculate data portion of datagram by data portion of MTU? So data portion of datagram is 5120 by data portion of MTU is 680. So 5120 divided by 680, you are getting 7.5. So overall you are having 8 fragments. Among the 8 fragments, first 7 fragments can have 780. So what does it mean? Your first fragment, if you consider, this is what your first fragment, this is what your second fragment, this is what your third fragment, and this is what your fourth fragment. So first fragment 680, second fragment also 680 bytes, third also 680 bytes, this is also having 680 bytes. So this is ranging from 0 to 679. This is ranging from 680, it starts with 680. So 680 and 680. So if you consider 680 into 2, 1359, it is ending with 1359 and it is starting with 1360. So 680 into 3, if I do 2040, so this is ending with 2039. Then this fourth one will start from 2040. So the first byte is 2040. So therefore offset is equals to offset of the fourth fragment. So offset of the fourth fragment is what? 2040 by 8. So 2040 by 8, if I do, I am getting 255. So 255 is the fragmentation offset value of the fourth fragment. So 255 is the answer for this question. Okay, right. So let's move to the next question. So look at this question statement. A distance vector routing protocol uses hop count as its metric, as its routing metric. Okay, what does it mean? To find out the shortest path, hop count it is considering as main criteria. The value 16 is treated as infinity. This is what main point. The value 16 is treated as infinity. Which of the following statements is are correct? The routing diameter is effectively limited to 15 hops. Yes, it is correct. So, the value 16 is treated as infinity. What does it mean? 1 to 15 are reachable. Or else the maximum hop count. This is what your maximum number of hops your packet can be reached to your destination from 1 to 15. Up to 15 it is reachable. But once it is 16, what does it mean? It is considering as infinity, means not reachable, unreachable, or else non-reachable, right? So that is why this statement is true. Counter to infinity stops when metric reaches to 16. See, counter to infinity stops. So counter to infinity stops when metric reaches to 16. So infinity you are treating as what? Infinity you are treating as what? Infinity you are treating as 16. So 16 you are considering as infinity. What does it mean? Once the routing metric is 16, you cannot reach your destination. But up to 15 you can reach. So it is speaking about what? The counter to infinity stops when metric is reaching to 15. When counting to infinity stops when metric reaches to 16, which is true, you can say, because it is not leading to the loops, right? So it is not stopping the loops, but counting to infinity is been stopping by 16. So that's why this particular condition is also true. But when it comes to option C, routing loops cannot exist once metric becomes 16. See, routing loops can be continue. Reason, 16 you are considering as infinity, means it is non-reachable. But you are not preventing the loops, you are continuing the loops. For looping prevention, you are using some split horizon, Poisson distribution concepts. But it is not related to your metric, routing metric. That's why this particular statement is false. Okay, routing loops controlling is not according to the hop count. It is with respect to split horizon and Poisson distribution. These concepts are there. We are using those concepts to limit these routing loops. So once the routing metric, the hop count is becoming 16, then you are saying that your destination is non-reachable. Okay, so that is why we can say this is false and option B is true. Then coming to option D, this limitation improves convergence time. Yes, it is also true. Reason, convergence is what? You are calculating the routing path in a faster manner. So since the metric is 16, you directly mentioned that it is unreachable, infinity. So there itself it is limitation is being improved. The limitation improves the convergence time because of this 16, or else because of this hop count value is 16. Obviously the convergence time is improving because it is a limit. You are not continuation of that routing path calculations up to becoming infinity. By 16 itself you are saying you are not reachable. So you are not going beyond the 16, right? So once it is becoming 16, your hop count value, then you are saying that it is limited. It is been not reachable, right? So that is the way how you can say that this limitation, what is the meaning of limitation here? Considering the maximum hop count value as you can say 15, or else if once the value becoming 16, then treating it at infinity, this is a limitation which is improving the convergence time, which is true. So overall, if you check, the answer for this question is A, B and D. Okay, so this is what the answer for this question. Next, look at this statement. Which of the following statements is about TCP error control are correct? So TCP uses checksum to detect errors in both header and data. Yes, it is true, because TCP is using the checksum to calculate the errors in both header as well as data. It is calculating the checksum for both header and data. Next, option B, TCP relies on positive acknowledgements only for error control. No, this is false. So TCP is using negative acknowledgements also, but not only positive acknowledgements, because TCP is the combination of both go back and selective repeat. Next, whatever the flow control it is using, that flow control, sliding window flow control is the combination of both go back and selective repeat. Then coming to option C, TCP uses retransmission timers to recover from lost segments. Yes, it is also true. Because of this retransmission timer, the TCP is able to do reliable transmissions again and again, right? So, which is true. So, TCP uses selective acknowledgements to improve retransmission efficiency. This is also true, because you know that whatever the sliding window that the TCP is using to handle the flow control, the sliding window is the combination of both go back and selective repeat, but its selective repeat behavior is more than the go back end. So, that is why this is also true. Only this option C is false here, okay. Only this option B is false here. So, TCP relies on positive acknowledgements only for error control, which is false. So, overall the answer for this question is A, C and D, okay. So, A, C and D.